Shifali Pandi ma'am. Good evening ma'am. Shifali ma'am, good evening ma'am. Ma'am, we will make you co-host, ma'am. We will make you co-host, ma'am. Please wait. Ma'am, co-host. Again, do it. Ma'am, good evening, ma'am. Good evening to all. We are assembled here for the 2-week virtual training program on research methodology and data analysis.
Good evening.
Yes, ma'am. Good evening. Shall we start, ma'am?
Yeah, I'm ready. I was not able to unmute myself. Somebody from your end, I think, did it.
Yes, ma'am. Yes, ma'am. Yes, ma'am. Shall we start now?
Sure.
Today, our session is on tool construction and validation by Dr. Shifali Pandya, ma'am, Senior Professor and Head Department of Education, University of Mumbai. Ma'am has 31 years of teaching experience at PG level and 10 years of administrative experiences. Ma'am has to her credit two independent research projects sponsored by UGC, funded by UGC University and UGC. Both projects are funded by UGC. Ma'am has visited UK, USA, France, Australia, Japan, South Africa, Singapore, Thailand, and Nepal, and presented 14 papers. Ma'am's academic achievements are: ma'am have produced 42 PhDs, 15 MPhils, published 145 papers, number of books published is 16. Madam has served as a resource person for giving keynote and valedictory address for about 14 sessions. Invited paper sessions as a resource person 66, session taken in webinars 8, published one psychological tool with copyright, namely Academic Resilience Scale from National Psychological Corporation, Agra 2021. Ma'am is member editorial board reviewer of various journals in both national and international level. Ma'am's additional experiences are: she is an active team member, coordinator, and from 2015 onwards, NCTE team member from 2005 onwards, member in various academic bodies, member in Board of Studies in Education. Madam has served as resource person for orientation program of UGC Academic Staff College in Mumbai University from 2005 onwards. Madam has served as a resource person for refresher course of UGC Academic Staff College in Mumbai University, Pune University, MS University of Baroda, and Saurashtra University. Madam has organized 23 seminars, conferences, and workshops, 2 webinars, and 3 refresher courses. We are happy to have you here, ma'am, for this session. I kindly welcome you to take over this session. Welcome, ma'am.
Thank you to IQAC cell of ANNAMALAI University and Madam Sailila for inviting me here to be with all of you. I'll be talking about constructing tools as well as validating it. That is a part of the process of construction. Let us begin with the session. Okay, today in my session, I'll be talking about the other word for tool is instrument. So instrument or tool, steps of constructing it, defining the terms, designing the instrument, types of validity, measuring content validity, other types of validity measurement, item analysis, discrimination index, difficulty index, index of measurement efficiency, types of reliability and improving it, sample size for pilot study, frequent mistakes caught through piloting, standardization, designing online instruments, survey pilot process, comparison of online and research and offline research, and online data collection. So it is a little long, so I will talk till 5:30, and the rest we will see whether we can come, but I will certainly deal with how to collect how to develop a tool and how to validate it. What is an instrument or a tool? An educational instrument or a psychological instrument is a measure of a particular educational, psychological, or social variable. These include, for example, achievement tests, aptitude tests, attitude scales, rating scales, personality tests or inventories, interview schedules, observation schedules, interest inventories, sociometric measurements, questionnaires, opinionaires, and a series of all other tools. The list is long. When we talk about attitude scales, there are several types within attitude scales like Likert type, Thurston type, semantic differential scale. So all those I will not talk about in detail, but we have several types, and all there is an umbrella term for this, namely a tool or instrument. Now, what are the steps in preparing a tool or constructing a tool? Yes, someone wants to ask the question. Please unmute yourself and ask.
One minute, ma'am. I'll enable that option. 1 minute, please.
Yeah.
Yes, they can ask, ma'am. Yes, those who have doubt can unmute yourself and ask.
Yeah, someone had raised hand. Therefore, I said you can ask question. You are free to ask in between. Please ask.
Aragadasan, sir. No, madam, you continue, madam.
Okay, it must have been by mistake then, no problem. But this is a standing instruction. If you want to ask, you please ask, no issues. Okay, step 1, conceptually defining the term, operationally defining it, designing the instrument, prepare a design. So in that you determine the type of instrument, whether you want to prepare an achievement test, attitude scale, questionnaire, what do you want to prepare? Determining the dimensions of the concept being measured, determining response categories, determining scoring patterns. Now I'll talk about this a little more in detail. Suppose you want to measure students' attitude towards the teacher. It means you want to measure attitude. As I said, there are 3-4 types of attitude scales. One such is Likert, second is Thurston, third is semantic differential. So when you want to measure attitude towards the teacher, which one would you prepare? Maybe you are a novice, you are a newcomer to research, you're not that experienced. So Likert type is the easiest of all. So you decide that first of all, you want to develop an attitude scale, that is determining the type of instrument required. So you have determined that you want to prepare an attitude scale. Then determining the dimensions of the concept being measured. So does attitude has dimensions? Yes, it has cognitive dimensions. It has emotional dimensions, and it also has behavioral dimensions. So these three are dimensions of attitude towards the teacher. Then you determine the response categories. So you decide whether you want to have 4-point response categories like strongly agree, agree, disagree, strongly disagree, or you want to have 5-point strongly agree, agree, undecided, disagree, strongly disagree. Or you want to have another 4-pointer scale, always, frequently, sometimes, never. So these are known as response categories. So you determine response categories and then you determine scoring pattern. Suppose you decide 4-point scale. Strongly agree, agree, disagree, strongly disagree. So your scoring could be 4, 3, 2, 1. So that is your scoring pattern. Now, before that, in step 1, you make a conceptual definition of attitude towards the teacher and operational definition of attitude towards teacher. Then you develop items. An item is either a question or it is a statement. If you are preparing an attitude scale, you may prepare statements and that is called an item. Then you establish content and face validity. Then you do item analysis. So this comes in step 1. In step 2, you establish reliability. Then you may determine discriminant validity if necessary. Then you may conduct a factor analysis if necessary. And thereafter, you finalize the instrument. And then step 3, now this step may not be necessary for all tools, all instruments. Step 3 includes developing norms for standardization. So step 3 is called standardization, but that may not be required in all research. Deciding the instructions to be given to the respondents and preparing a manual for test usage. So there are 3 steps in conducting, in developing a research instrument. I'll talk about each one in detail. Defining the term. Yeah, what is it? So I'll give some examples of a conceptual definition and an operational definition. So example, I'll take the concept of teacher effectiveness. So when you define teacher effectiveness conceptually, it means a teacher is said to be effective if he or she achieves her objectives. An operational definition, a teacher is said to be effective if her students attain proficiency in the subject taught by her in terms of minimum score of 60% academic performance after adjusting for SES. So, if you achieve your objectives, then you are an effective teacher. That's the conceptual definition. But when you operationally define it, it has several aspects. One is if students get minimum 60%, now that 60% marks also depend on several other factors which are inherent in the student, like student's socioeconomic background. So that also will have an influence on students' marks. So after you make adjustment for students' socioeconomic status, after that, if the student gets 60%, then the teacher is said to be effective. So that's the operational definition. The operational definition may also include the criterion to be used in assigning an individual to a group if it is either a causal comparative study or an experimental study. Now, so far, if anyone has any questions, you may please ask. Otherwise, I will proceed with the PPT. Do you have any questions? No? Okay, fine. Okay. Next point is designing the instrument. How do you design? Determine the type of instrument required. Self-report, rating scale, questionnaire, observation schedule, interview schedule, achievement test. Out of these, which I've mentioned here, rating scale, questionnaire, achievement test, attitude scale, these are all self-report because the researcher prepares it. If I'm the sample, I'm the respondent, researcher will give it to me and I will give a response. So I report about myself. So these are known as self-report. But if it is an observation schedule, then if you are the researcher, you will come, you will use the observation schedule, you will observe me and you will note down. Similarly, if an interview schedule is prepared, then it is you who will conduct the interview and you will note down my responses. So observation and interview schedule are not self-report instruments. Here the responses are reported by the researcher, but the other types are self-report instruments. Okay. Determining dimensions of the concept being measured. For example, if we are measuring classroom climate, then in the classroom climate, there are several dimensions. One dimension is relationship amongst peers, relationship with the teachers. So that becomes relationship dimension. Second one, every classroom climate is meant for students' development. So second dimension is personal development dimension. And third, because there are many people in a classroom, some system has to be decided and maintained also. And that may include rules, how rules are developed, how rules are maintained. So that is system maintenance dimension. So in this particular example, 3 dimensions have been mentioned: relationship dimension, personal development dimension, and system maintenance dimension. For example, this is an example. So you determine the dimensions of the concept being measured. Then you determine response categories. I have already given an example. AFSN means always, frequently, sometimes, never. SAAUMDSD means strongly agree, agree, undecided, disagree, strongly disagree. Or alternatively, you have a 2-point scale called yes or no. Then you determine the scoring pattern: 4, 3, 2, 1 for the first type, 0, 1, 2, 3, 4 second type, or -2, -1, 0, 1, 2. That also could be done for the second type. So there are a lot of choices that are available, and you have to decide what should be the response categories and what should be the scoring pattern. We continue. As a first step to tool development, the researcher needs to apply a theoretical basis to develop the items. The researcher should carefully examine the existing theory relating to the variable he or she wishes to measure. So if you are preparing a tool on classroom climate, you have to read on theory of classroom climate. Read it very carefully. There might be 2-3 theories available. Then if there are 2-3 theories available, you may read all, then make a general evaluation of all the theories and decide which one will be suitable for your research. And based on that, you can prepare your tool. Why do you read a theory? Because a theory can provide a guide in terms of developing the conceptual formulations required for operationalization. Examining theory helps to establish the parameters, domains, dimensions, factors of the variable, so that your tool is focused on the actual concept that you are measuring, and you can avoid unrelated areas. So I earlier mentioned that you determine dimensions. Here, instead of dimension, you can call it parameters, you can call it domains, you can call it factors. It means the same. Now, you design the items. You develop the items. As I said earlier, an item is either a statement or a question. So if you are preparing a questionnaire or an interview schedule, you may prepare questions. If you are preparing an achievement test, even then you can prepare questions. But if you are preparing a rating scale, attitude scale, interest inventory, then you may prepare statements and not questions. So developing items or generating items requires a lot of efforts, because you can't prepare one statement and say this is final. You may read and you may find that it is clumsy, it is ambiguous, it is too long. People don't understand it properly because it has double meaning. So you have to write and rewrite and again rewrite. You have to refine its words and content. Plus, a key strategy in item development is to keep in mind the research questions. What are your research questions? What are the objectives of your research? And then ensure that the items that you prepare, your questions or your statements, represent the research questions and they are relevant to your theme of research. During this stage, if you have dimensions, then you have to prepare questions or statements on each and every dimension, so that the items are representative of these. You have to start with a large number of items, then what may be required. And this large number of items is called a pool of items. For example, if you are preparing an attitude scale, generally the theory says that around 24 items are sufficient in an attitude scale or a rating scale. So ideally, if 24 or minimum are required, then you prepare about 35-40 items. And those 35-40 items is called a pool of items. You may finally require only 24, but you write down at least 35-40 items. It is essential. Why it is essential, we will see later in other slides, following slides. Now, next step is types of validity. What are types of validities? We've got 6 different types of validity. My title of the session today that I'm given is Developing a Tool and Validating It. So now we are validating the tool. And there are 6 different types of validities. First one is called, this bottom one, content validity. This one, content validity. Next is face validity. Then you have criterion validity, which is again of 2 types, concurrent validity and predictive validity. Construct validity, which is again of 2 types, convergent validity and discriminant validity. Then you have consequential validity, and then you have known group validity. Generally, in most researches, people establish content validity and face validity. These are done very rarely in Indian researches. But these first two, content and face validity, are usually established in most researches. How to measure these 6 types of validity? So now next point is measuring content validity. Okay. First one, most important, is content validity. How do you establish? There is a formula also available for it. Loesche developed a formula termed the content validity ratio. And I've given the formula here. CVR is content validity ratio. NE minus N upon 2 divided by n upon 2. Now, what is it? Any means number of subject matter experts, indicating essential. N is the total number of subject matter experts, and this formula yields values which range from +1 to -1, where positive values indicate that at least half the experts have rated the item as essential, and the average CVR across items may be used as an indicator of overall test content validity. Okay, अभी मैं बताती हूँ ये what is it. I'll tell you. How do we do? I'll give a concrete example for this. Okay. I 2 minutes task to everyone. Suppose we are measuring a tool for teacher effectiveness, perceived teacher effectiveness. So perception of whether a teacher is effective or not. And I want you to prepare at least total together, all of you, Milake, you prepare at least 10 statements which measure teacher effectiveness. I'll give you one example. Based on that example, you can prepare other items, statements. My teacher comes to the class well prepared for the subject that he teaches. This is one statement. You please prepare similar 10 statements. I'm giving you 5 minutes to prepare that. If you wish, I will stop sharing just now. I'll continue later. We can write in the chat box if you want. I'm writing the one statement in the chat box. People have started writing. Very good. Tamanna has written, my teacher manages the class well. Very good. Very good. Please prepare at least 9 such items. From different people, I want different items. Please write in the chat box. Yes, we want a mix of statements. Some statements can be positive, some can be negative. Okay. My teacher rewards positive behavior. Students are able to answer her questions correctly. Okay. My teacher covers the syllabus. My teacher assessments are transparent and fair. My teacher always enters the class on time. Yes. Then my teacher communicates clearly. My teacher engages the class properly, corrects inappropriate behavior. Students understand effect. Very good, very good, very good, very good. Now you have to first define what is, yes, plenty of, and I am getting a very good response. I'm very happy with the group, that the group is very active. Yes, attitude is positive, keeps everyone engaged with her lecture. Presentation is very nice. Yeah, encourages active participation, explains nicely, motivates students. Students are interested to learn mathematics. Teacher's knowledge is good, keeps everyone engaged with her lecture, clarifies other general subjects. Yes, yes, yes. Very nice, very nice. So now we will proceed with the content validity. You prepare, doesn't discriminate. Okay, now first you define teacher effectiveness. So we can define teacher effectiveness as follows. Teacher is said to be effective if he or he has command over the subject knowledge, encourages
हवा चल रही है क्या उड़ के आते हैं
and
हाँ
engages students,
बढ़िया बढ़िया
pays individual attention, uses varied methods of teaching and shows professional behavior. Now, when I say shows professional behavior, I include so many things like coming to the class on time, being fair and impartial, all that comes under professional behavior. So first you define what is teacher effectiveness, and then all those statements that you have prepared, you write within below that definition, and then give the entire tool, the definition and the items to experts. Say you give it to 10 experts in the field of education. And next to each statement, you prepare 2 columns. And you tell their experts, 10 experts, that please read the definition and read the statements below it. If the statement matches the definition, you put a tick mark in the column relevant. And if you feel the statement does not match the definition, you put a tick mark in the irrelevant comment. So 10 experts will give remarks for each of the items. Okay, now I'll share the PPT again. So now you see number of subject matters experts indicating essential. So take first statement. All 10 experts have said that this statement is relevant or essential. And total number of experts is 10. So your CVR will be 10 minus 5 upon 5. That is 5 upon 5 equal to 1. So for statement 1, CVR is 1. Let's take statement 2. 8 experts have said that the statement is relevant. 2 have said it is not relevant. So your NE is 8. 8 minus 5 upon 5. So it is 3 upon 5. It is 0.60. That way, for all 35 items, you prepare your CER and then take the average value. Average value gives the overall test content validity. I hope this is clear now. If you are not clear, please unmute yourself and ask a question if you are not clear about this.
Excuse me, ma'am.
Yeah, please.
Please, can you repeat the formula, ma'am? Explanation of that formula with the example.
Yeah.
Thank you so much.
You have prepared 35 items, right? For measuring teacher effectiveness. Take the first item. You have given the definition and all the 35 items to 10 experts. And each expert will indicate whether each item, each statement matches the definition or not, and whether the item is essential or not. Take item 1. You have given it to 10 experts. All 10 experts feel that the item is necessary, essential. So see here, all 10 have said that item is essential. So your NE, this one, NE is equal to 10. What is the total number of experts? 10. So when you put these values here in the formula, NE is 10, Your n upon 2 is 5, 10 upon 2. And this n upon 2 is also 5. So 10 minus 5 upon 5. That is 5 upon 5 equal to 1. I'll give you one more example. Second statement, only 8 experts out of 10 feel that the item is essential. So NE equal to 8, N equal to 10. So 8 minus 5 upon 5, that is 3 upon 5, that is 0.6. Yes.
Ma'am, no is clear.
Ashini, you have raised your hand. Please ask.
Ma'am, that means the values will be between -1 and 1. So
Yes.
what numbers do we criteria? Which one we will take?
No. Here what you need, see what it indicates, positive values indicate that at least half the experts have rated the item as essential. And it should be essentially positive. All answers should be positive. Once you get all the answers, you take the average value of all the answers, and that average value is the overall test content validity.
Can you repeat it again, ma'am? The last part.
Okay. I'll write it in the chat box. Huh?
Yes, ma'am.
That would be easier for all of you to understand. I'll write in the chat box. Item 1, answer is 1. Item 2, answer is 0.6. Similarly, item 3, answer is 0.9. Item 4, answer is 0.7. Item answer is 0.4. Okay. These are the CVRs for 5 items. I'm taking only 5 items. What is the average CVR? Tell me, please. Will you please give me the average CVR?
0.8.
I have not done it, so please do it and tell me. I'll rely on you.
It's coming 0.8.
Okay, fine. 0.8. Fine. Let's proceed with this. You will understand it very well. Don't worry about it. So your overall test content validity is 0.8. Rengaraju sir, you have a question? You have raised your hand. Sir, if you have a question, please ask. Okay, now how to do this further?
Ma'am, to be precise, it is 0.72. Do we take the 2 decimal?
No, we take 0.72 then. Let it be 0.72.
Okay.
Okay. Now in this table, look at this. Number of experts we have taken is 10. So what should be the minimum value? 0.62. And you got it as 0.72. So the content validity of your tool is adequate. It is good. If it was 0.54, it would have been less than 0.62. So it would not have been good. But you got it as 0.72. So for 10 experts here, for 10 experts, this minimum value 0.62 you are crossing. You are getting 0.72. So it is a good content validity. Is it clear now?
Yes, ma'am.
Yeah, sure. Shall I proceed with the next one? Next,
Yes,
slide.
it's clear.
The next slide. Friends, please answer. Shall I proceed with the next slide?
Yes, ma'am.
Okay. If you have understood, then we will go. See, if you had given it to 5 experts, your minimum value should have been 0.99. If you had given it to 7 experts, then also it would have been 0.99. So if you look at this, more the number of experts, less value is okay. Generally, for my students, I make them give it to 8 to 10 experts. So around 7.78 to 0.62 minimum value if we get, that is sufficient enough. Next, other types of. So this is content validity, which is very important, and most people in the field of education establish content validity. This is a numerical indicator of content validity for your tool. Now we look at other types of validity. Okay, let's look at that. First, you establish content validity and face validity. Now, to ensure face or content validity, items can be generated from a number. So you first write down items, statement or questions, then give it to experts. Then experts will tell you whether the items are relevant or not. And you calculate CVR, that is content validity. Now, I'm giving you one example. You tell me whether content validity is there or not. Sorry, you tell me whether face validity is there or not. I'm giving you some statements. You tell me. I don't like to go to school. I wish all days were holidays. All 7 days were holidays. I love my teachers and therefore I love going to school. My school is the best school in the world. Now, when I give you 4 statements, tell me, what am I measuring?
Attitude of students going to school.
Attitude towards the school. My school is the best school. So you are absolutely correct. Attitude towards the school. That means my tool has good face validity. On the face of it, when you look at the items, you can guess what it is measuring. It means the face validity is good. I'll give you one more example. Online teaching is the worst thing in life. I enjoy teaching online because it gives me a lot of scope to teach at different timings convenient to me. I don't think online teaching is a good thing because you can provide content matter, but you cannot develop skills, values, ethics in students through online learning. Due to technological advances, online things is the best thing that we have ever seen. What am I measuring?
Teachers' perception towards online teaching.
Yes. So the face validity of my tool is good because just by looking at the items, you could guess what I'm trying to measure. So that's face validity. Am I clear about this? Rangaraj, you want to ask a question? You have raised a hand. I think it's by mistake. Okay.
Ma'am,
Yeah.
do we only decide the face validity or we ask our guide or
Give it
supervisor?
to experts.
Give it to the experts. Okay.
Yes. They will decide. But there is no mathematical or numerical indicator for face validity. For content validity, we have a numerical indicator, which I showed you in earlier slides. But for face validity, you don't have a numerical indicator. They will just tell you whether what it measures. That's face validity. Okay, now we proceed. Okay, then you the type of the tool, the language used, the order in which you are writing the items are also very important. A controversial or emotional issues should be asked at the end, and general issues, non-emotional issues should be asked first. Then to engage participants and prevent boredom, demographic and personal data can be asked at the end. Double negatives should be avoided in the questions. And ideally, if you have 35 items, roughly half should be positively worded, half should be negatively worded. For example, today in technological era, online teaching is the best thing, is a positively worded item. But if I say that online teaching is not very useful because you cannot develop ethics, values, and attitudes and skills in students, then that is negatively worded items. So you have minimum half negative, roughly half negatively worded items and half positively worded items, so that you can avoid bias and prejudice. There are people who just put tick mark, yes, yes, yes. So if you have all positively worded items, the score will be very high, and that cannot happen. So therefore, ask half negatively worded and half positively worded items. Okay. Next is item analysis. Item analysis is a process of examining class-wide performance on individual test items. Now remember, an item analysis involves statistics.
I have a question.
Yes, please.
Hello.
Please ask.
Ma'am, in the face value, number of question, what percentage should we consider, ma'am, for to be a good face value for a content analysis?
See, there is no mathematical indicator, but if the items are prepared well, generally all experts can tell you whether what the items measure. So there is generally you don't face problems in measuring face validity, and you need not give that to 8 to 10 experts. Even if you give it to 5 experts and they just write a word about what you are measuring, that is sufficient.
Okay, ma'am.
An item analysis involves many statistics that can provide useful information for improving the quality and accuracy of items. First is discrimination index and second is difficulty index. Now there is an important point that one needs to keep in mind here. Discrimination index can be calculated for achievement tests, rating scales, attitude scales, for everything. But difficulty index can be calculated only for achievement test. Difficulty index only for achievement test, whereas discrimination index can be computed almost for all types of tools. Okay, now we look at discrimination index and difficulty index. How to compute discrimination index? What is it? Item discrimination. It's a basic measure of validity of an item. Now, earlier we computed content validity and face validity. That is for the entire tool. Now, we are computing validity for each item, each statement or each question. That is called discrimination index. It refers to the relationship between how well respondents scored on the item and their total score. It's a measure of an item's ability to discriminate between those who scored high on the test and those who scored low. Though there are several steps in its calculations, once you compute it, this index can be interpreted as an indication of the extent to which overall score of the entire tool is related to the response of an item. And perhaps this is the most crucial, most important validity standard for an item. Earlier validity, content and face validity was for the entire tool. Now this is for each individual item. The procedure. The procedure for calculating discrimination index of an item is as follows. This method is suitable for achievement tests as well as other types. First, arrange the total scores obtained by all the respondents on the tool or test in a descending order. If you wish, I will prepare an Excel sheet and show you. You want to see how it is to be done in practice?
Yes, ma'am, that would be really nice.
Okay, then I'll stop sharing this PPT and I will prepare and show you how to actually do it in practice. I'll share an Excel sheet. Okay, can you see the Excel sheet? Someone can please reply.
Yes, madam.
Yes, ma'am. It's
Okay, fine.
ma'am.
Now,
Yes, ma'am.
yeah, okay. Here, first would be statements. Then you have strongly agree, agree, disagree, and strongly disagree. First statement will measure teacher effectiveness. See, I have roughly 3 statements positively worded and 3 negatively worded. Now, students give responses to this. I will now change the format of this particular tool. These are the statements. I'm changing the format now. Pay attention. I purposely wrote like this so that you understand what I'm doing. So these are the statements that I have. Now, my response categories are strongly agree, disagree, strongly disagree. And my scoring pattern is 4, 3, 2, 1. So now, in the first column, I have students. Here I put students. First student number 1. First student agrees to the statement, this strongly agrees, so 4. Agrees to second. Teacher engages the students very well, 3. Here she gets a score of 4, here she gets a score of 2, here she gets a score of 3. And then you find the total score. Here you get the total score. So here for this particular person,
Daddy, money 5 மணி ஆயிடுச்சு.
19, ma'am.
so the total score for the first student is 24. Now student number 2, student number 3, 4, 5, 6, 7, 8. That way I will take data from say 100 students. I will go up to 100 students. And these are their scores. I'm just roughly writing the scores. This way I will write. Sorry, here you will write the total scores. So I get scores of 100 people. Now I focus only on this part, these scores of all 100 students. Okay. My focus now will be on this, and I will arrange these scores in a descending order. So the highest at the top and then at the bottom. Now I will stop sharing this and I will go back to my PPT. There are some chats, so I will better read. You are putting, yes, somebody is, Madam Subhashini is asking, negative items will have reverse order of numbers scoring. Yes, Negative items will be scored in the reverse order. Correct. Now let's go back to the PPT. So you have seen how I have shared the how I have arranged the total score. How I have put all the scores, put the total score, and I also arranged the total scores in a descending order. Now, if I had 100 students, I take topmost 27 students and bottom 27 students. The middle one, 43%, 46%, I avoid. I don't use that. So upper 27% scores and lowest 27% scores. That will decide my discrimination index. Okay, now there is one, this formula which I put here is called Johnson's formula. That also can be applied, and we can also use point biserial for computing discrimination index. So this formula which I have written here is called Johnson's formula. This can be used, or you can also use point biserial coefficient of correlation. Both are equally allowed. Now, how do you interpret? Discrimination index of each item ranges from -1 to +1, and all those items whose discrimination index is 0.22 or higher, you have to keep in your tool, and if some items are less than 0.22, then you remove them. And this was the reason why I had told you that if you require about 24 items, begin with 35 to 40 items, because if the discrimination and difficulty index of the items are not appropriate, you may remove that, you may have to remove that item. So even after you remove some items, then you are left with sufficient number of items, say for example 24 or 25, and therefore begin with many more items, a pool of items, say 35 to 40 items. So that is how you calculate discrimination index. Now we look at difficulty index. Difficulty index is to be computed only for achievement tests, not for other tests. It refers to the percentage of students that correctly answered the items. See, if the item is easy, very easy, all the students, 100% students will answer it correctly. But if the item is very difficult, very few students will be able to, only 1 or 2 students will be able to answer it correctly. So its value ranges from 0 to 100. Either nobody answered that question correctly, so value is 0, and all answered it correctly, value is 100%. So it ranges from 0 to 1. Higher the value, easier the item. If all students, 90% of the students answer it correctly, the item is easy, and therefore value is 90% or 90 upon 100 or 0.9. It means higher the value, easy item, lower the value, difficult is the item. Now ideally, if you are preparing an achievement test, 25% of the items should be very difficult, 25% should be very easy, and rest of the 50% of the items should be of average value. That is how you calculate difficulty index. And difficulty index means R upon N. R is the number of students who answer the item question correctly, and N is the total number of items, total number of students who answered the item. The ideal value lies slightly higher than midway. So around 0.6 or so, because that's the average number of people who can answer. 0.90 and above are very easy items. 0.1 or 0.20 and below are very difficult items. So keep 1 or 2 items very difficult, 1 or 2 items very difficult, very easy, and the rest should be of average difficulty value. That is the general rule for preparing an achievement test. The next is index of measurement efficiency. If it is an achievement test, you compute difficulty index, you compute discrimination index, and you also can compute index of measurement efficiency. And I'll put it here where index of measurement efficiency IME is equal to 1 minus 0.16k upon standard deviation squared, where k is the number of items and sigma squared is standard deviation. And if you get this IME is 0.75, that is adequate index of measurement efficiency. So measurement efficiency of your achievement test is adequate if you get this as 0.75. Next is types of reliability. 4 types: internal consistency, test-retest, parallel form, and inter-rater. Most researchers compute only the first 2 types, namely internal consistency and test-retest. If you are measuring internal consistency, there are several mathematical or statistical indicators such as split half, Cronbach's alpha, White's-ANOVA, Rulon's formula, Kuder-Richardson, and Gutman's. And test-retest reliability is measured using coefficient of correlation. The parallel form is also measured using coefficient of correlation. This is very useful in experimental research. And then finally, you have the inter-rater reliability, where you either can compute coefficient of concordance or you can compute kappa coefficient. Internal consistency. Now this I'll just skip this because that's more mathematical part. Okay, now I'll come to sample size for pilot study. Okay, see now this. What should be the reliability coefficient? If it is above 0.90, it is said to be excellent. If it is between 0.8 and 0.9, it is good. If it is between 0.70 and 0.79, adequate. If it is less than 0.70, you have to revise your tool. Your tool is not appropriate, you have to revise it. Similarly, test-retest reliability. If it is greater than 0.9, excellent. Between 0.8 and 0.9, good. 0.7 and 0.8, acceptable. Between 0.6 and 7 onwards, reliability is not good. You should not be using that tool. So it has to be greater than 0.7. Yeah, what should be the sample size for pilot study? Statistically, a sample of more than 30 is called a statistically large sample, but 10 to 20% of the main sample size is a reasonable number of conducting a pilot study. This is an indicator. So if you are in your final sample, you plan to have 500 people, then at minimum 50 to 100 people should be there in your pilot study, because you want 10 to 20% of the main sample. That should be your sample size for pilot study. This is a thumb rule. What mistakes people make in piloting? The words that you have prepared, inconsistent words and spelling errors. For example, There are some people who in one statement, they will write COLOR, color, COLOR. And in the second statement, they will write COLOUR. So they are somewhere they will write US spelling, somewhere they will write British spelling. This cannot be done if you choose one and stick to it. Then bias in questions or answer wordings, requesting inappropriate demographic data, overlapping question scales or selection points, inaccurate or missing instruction, technical vocabulary with no definition, insufficient space for open-ended questions and answers, lack of motivational techniques to go to the survey and or complete it. So this is sometimes people make such mistakes. What mistakes you made at the time of administering the tool? Okay, one of the most important distinctions relates to whether tools you administer it to the students individually or in groups. Most of the tools can be administered in a group, and therefore you have to prepare a tool booklet and an answer sheet so that respondents can give their responses. Some tools these days are also administered online these days, like in the form of Google Form. There may be some adaptive qualities to test administered by computer, although not all computer administered tests are adaptive. You have to learn how to prepare a Google Form and how to send it to people for responses. Okay, what more about tool administration? Either all questions are answered in a linear form or it is like adaptive. If your answer to the question number 1 is yes, then go to the question 2. Otherwise, go to question 3. That will be adaptive. Okay. Now, since we are talking about validity, a validation of the tool, standardization also is an important part. Standardization is the uniformity of procedure in administering and scoring a tool. It implies that scores obtained from different respondents under the same administering conditions can be compared. It implies uniformity of procedures in administration and scoring of the tool. If tools must be standardized, they should be reliable and valid. So first, determine content and face validity. Okay, I'll give you this thing, and then a last step is to calculate norms. That will be the procedure. Now I'll give you the procedure. I'll tell you the procedure. Step 1. Decide what do you want to measure. You want to measure teacher effectiveness. So first write down definition, the conceptual definition. A teacher is said to be effective if he or she fulfills her objectives. That is a conceptual definition. Then write the operational definition. A teacher is said to be effective if he or she has command over the subject matter, manages the students well, uses different methods of teaching, possesses professional qualities such as honesty, punctuality, objectivity, unbiasedness, and so on. Builds a good rapport with students. So this is my operational definition of the concept. So first step is decide which concept and provide 2 definitions. Then decide. Now for measuring this, I think rating scale would be good, and the response category would be strongly agree, agree, disagree, strongly disagree. So if I've decided to use rating scales, I have 5 things in my definition. So I have 5 dimensions of teacher effectiveness. So I will at least prepare 8 items for each dimension. So if I say first dimension is teacher's command over subject matter, then I will have at least 8 statements to measure teacher's command over subject matter. If I say teacher possesses professional qualities, I should have at least 8 statements which measure professional qualities of a teacher. So total I have 5 dimensions. So I will begin with 40 dimensions. This is my first step. Step 2 would be I have prepared 40 items. Now I write the conceptual and operational definition, below which I write 40 items, and then I put 2 columns next to each item, relevant, irrelevant, and I give it to 10 experts. Based on their responses, I calculate content validity ratio, CVR, for the entire tool, for entire teacher effectiveness scale. Then I give it to about 5 experts without the definition and without name of the concept. I give only the items and ask the 5 experts to mention what it is measuring. All of them give me a response that the tool measures teacher effectiveness. So in the first step, I have mentioned content validity. Now I'm measuring face validity. That's over. Now I compute discrimination index of every item. Now till computing a discrimination index. So when I measure concept validity and face validity, maybe the expert may suggest and I may remove 1 or 2 items. Then I compute discrimination index. So if the items have discrimination index of less than 0.20, I may remove some items, and therefore I began with 40 items, but now my tool only has 29 items. It's fine with me. 29 items is sufficient for my purpose. So content validity, face validity, and discrimination index. Up to this I was establishing validity of the tool. Now I will establish reliability of the tool, internal consistency, and test-retest reliability. So the second step is to establish reliability of the tools. I have done that. So my tool is valid and reliable. Now I had 5 dimensions, and I think there are too many dimensions. I don't want 5 dimensions. I want dimensions to be reduced. So I may conduct a factor analysis. This is not necessary for all research, but sometimes some researchers want to reduce. So they may do factor analysis. So factor analysis, after I do that, my 5 dimensions may get reduced to 3 dimensions with 29 items, but only 3 dimensions. Now my tool is final, reliable, valid, and compact with only 3 dimensions and 29 items. Then I may administer this particular tool to say 800 to 1,000, 1,200 students, and based on the responses, I calculate norms. Norms could be calculated for the entire sample. It may be calculated separately for girls and boys. It may be calculated separately for primary and secondary schools or standard wise, 8th standard, 9th standard, 10th standard. It may be computed separately for urban and rural samples. So depending on your purpose of the study, you may compute norms, and then you write the entire procedure, entire tool, and your content validity ratio, your face validity, your internal consistency reliability, your test-retest reliability, your factor analysis results, and your norms. Prepare a booklet which should also include instructions of how to administer the tool. And ideally, my suggestion is you can also publish this. And this is the overall process of tool development, including its validation. Now, about 9 minutes are left, which I have kept for your questions. Often when I take this session, people ask questions. So based on my past experience, I've kept aside 9 minutes for questions.
Good evening, ma'am. Ma'am, if a tool is already developed and if it is already standardized, so is there need for validation for such tool?
See, what happens is, if the tool has been prepared in the Western countries, the social context sometimes may be different. The climate in classrooms over there is different from climate in classrooms here. The types of rules are also different in different social contexts. So if that is the case, then you do its reliability and validity, especially reliability in the Indian context. And norms also may be different in the Indian context. But there are some tools which may not depend on the context or the culture. Then you need not do it again.
Because
And
one
then-
of the in one of my study which I am doing, the tool which is developed is westernized. As you said, it was for lower classes, for 5th standard students, and the language which is to be understood was very difficult. So in that case, reframing of the questions of the statement is required, and should it be done in consultation with guide, ma'am?
So you do it again and establish reliability and validity again.
Ma'am, there
Okay,
are
okay,
two
ma'am.
questions in the chat box.
Yes.
What are the criteria to standardize the tool by Subhashini Raman?
We don't have criteria. Depending on the purpose for which you have developed the tool, you can standardize the tool and calculate norms gender-wise, urban, rural residence-wise, or class-wise, 8th standard, 9th standard, 10th standard. So depending on that. And my suggestion is, if you are preparing the tool only for correlational or causal comparative research, then do not calculate norms. It's not required. You prepare the tools for counseling or other purposes, then only you prepare the norms. Otherwise, there is no need for preparing the norms.
How to do Kronberg alpha questionnaire?
Okay. There is one, if you go to Google and write free online Excel sheet for computing reliability, there are reliability tools like that. Online Excel sheet is available. You take your data, copy and paste it in that Excel sheet. Within fraction of a second, you get your Cronbach's alpha and split up. You don't have to apply any formula.
Excuse me, ma'am.
Yeah.
This is Subhashini. I asked about the criteria to standardize the tool. What I meant was, does it have any minimum number of sample size to standardize?
Generally, when you want to standardize, you are establishing norms and you are telling people, see, for example, if you have prepared an IQ test, then you have to do it on a very large sample, like 1,000 and sometimes even more, because you are establishing a criterion. The average IQ of a 10th standard child is this much. If you want to establish that kind of criteria, it has to be based on a very large sample. You cannot do it on a sample of 100.
Okay, thank you, ma'am.
Then accepted value for a Cronbach's alpha, 0.7 and above is okay. Cronbach's alpha also depends on the number of items. If the number of items are more, your alpha value will be higher. So when you are doing calculations and if your Cronbach's alpha is low, then add a few more items. Your Cronbach's alpha would be better.
Madam, Kronberg alpha can be applied for SR type tool, ma'am. Questionnaire. SR tools, questionnaires. We can apply a Kronberg alpha?
Yes. Yes.
Okay, ma'am. Thank you. There is one question in the chat box.
Is there any particular way to set norms for leak? No. I'll check if I get that 1 minute. I'll just show you. Please wait. have done a Google free online Excel sheet for computing reliability. See, now here you get a Excel spreadsheet or XLS. Click on that. Just now I'm unable to do it, but click on this Excel spreadsheet or XLS. One sheet will open. There you copy and paste your data. You will get your reliability. Okay. Now, since this is not opening, I will take up the last one question. Minimum, how much statement should be in each one? See, as I said, you mix both a positive and negative. The books don't give you any minimum items, but for most scales, minimum 24 is required. So when you want minimum 24, start with a mix of positive and negatively worded items. As I said, about 35 to 40, because when you compute content and face validity and discrimination and difficulty index, some items will go and you will be left with minimum 24. Is that clear? Okay, Subhashini madam, you have raised your hand. Please ask.
I have typed the question, ma'am.
Yeah. Ideally, you have to take permission from the original author, or you prepare your own.
Even if we adapt it, like if we take only the components and do it?
Yeah, take permission.
Okay, thank you, ma'am.
Okay. I think we have come to an end of the session. Now many questions are coming forward, and I take this opportunity to thank you, IQAC cell of ANNAMALAI University, and of course, Madam Sai Leela, and of course, wonderful participants who have been very participative and active. So I'm very thankful to all of you, and hopefully we may meet in future in some other programs like online programs like this. Thank you.
Surely, ma'am. Now I like to invite Dr. K. Pravina, ma'am, Associate Professor, to propose thanks for this session. Ma'am, please.
Good evening, madam. Good evening to the participants. Madam has dealt with the following. She has dealt how to construct a tool, what are the various steps involved in the construction of the tool, and what are the various types of validity. She has explained with example the content validity and face validity, which all the participants would have enjoyed, because she gave many instances of examples, which was really well received by the participants. She also explained the difficulty index, discrimination index, measurement efficiency, types of reliability, how to do pilot study, and determine the sample size. On the whole, madam, your presentation was neat and very, very effective. The participants were highly beneficial. Thank you, madam, for accepting our invitation and being with us. Thanks a lot, madam.
So all the best to all of you.
Thank you, madam. Thank you, madam. Okay, can we continue with the next session, sir?
Yes, sir. Are you ready, I think?
Sir?
Good evening, sir. Good evening, sir.
Sir, unable to unmute.
No, sir is co-host. He can do it. Sir, good evening, sir.
Yes, good evening.
Sir, can we start with the session, sir?
Yeah, I'm ready for it. Yeah, sure.
Okay. Good evening again once more. Good evening, sir. Today I'm happy to introduce again Professor Pariksha. from Department of Statistics, HL College, Ahmedabad. He is an associate professor of statistics. He has acquired his analytical skills from attending various institutions like CMC, Vellore, IIT, Kharagpur, Hyderabad, and Duke University, USA, and IBM. He has served as a resource person in many workshops. He has published 25 research articles in journals of repute, and he is providing consultancy services to various institutions. He has published 15 books. Some of his books are published by the famous publisher Tata McGraw-Hill. Such a resourceful person is here to handle the session today on hypothesis testing. Sir, the platform is yours.
Thank you, ma'am, again for a nice words of introduction. And thank you, Shailina ma'am, for giving an opportunity again to interact with a wonderful crowd, wonderful participants that we have over here. So, good evening, everyone. You are now aware about the basics about the data, basics of summary statistics, and you're also aware about how to input your data, because the last 2 days it was about exploratory analysis of data using SPSS, how to enter the data, what are the points that you have to take care about entering the data in SPSS, and the basic how to use SPSS. Now tell me, how many of you, just you can write down in the chat box, how many of you have used SPSS for your own data analysis? How many of you have used it? So that I can plan my session accordingly. Okay, 1, 2, 3, 4, 5, 6. Okay, numbers are increasing. Trial version, it's not an issue. Okay, Sanjay sir, not an issue if you have not used. Almost 10 and 12. I'm new to research. Okay, no issue. Fine. Okay. So I guess I'm getting the number around 20, and the numbers are increasing. It is 20, 22 probably. Yeah. Just beginning. Okay. Fine. Okay. Why I ask this? Because if you are knowing about SPSS, if you are knowing any of the menu-driven softwares for data analysis, even Excel, you know, there is a data analysis tool pack in Excel, which you can use for basic data analysis that can be done. Right? Basic analysis can be done even using simple Excel. There is a plugin tool, there is an add-on, we can say, add-in in Excel, where you can plug in and you can use your data analysis tools for that. SPSS is more preferred compared to others because it is giving a very good output which can be interpreted, and it can be utilized for your research papers also and research projects also. Even R is one of the software which is an open source software, but it is a little bit of programming language. And I would say the non-statisticians and non-programming persons like us stay away from the programming part. So that way we can see that SPSS comes to a great help for the person who is now beginning into the research and or might be using the research for their own purposes. So before I go on with the hypothesis testing, one of the very, very important part for your own research and for real life also, for the industries also. Yeah, Subhashini ma'am, there are many software. JSSP is also used, even says Excel Stat is used. There are many other menu-driven softwares that can be used. I'm not saying that this is the only one. I'd say this is one of the software which can be very useful for you. And at least what you can do is you can use a trial version of SPSS if you don't want to buy. You can use a trial version of SPSS software if your institution doesn't have, and you can use a data analysis for your purpose. And again, you can use a trial version again with some other name and so on. So that is not a big deal to get an SPSS trial version for it. You can utilize it. Now, in the last session, if you recollect, we are done with the types of data, and I said that why it is important to understand the level of measurements, right? Why it is important to understand the level of measurements. The purpose now, it is very clear, if you recollect the last session, that there are three main purposes of understanding the level of measurements of your data. One is to understand which summary statistics to use, whether to use mean, median, or mode, whether to use standard deviation, range, interquartile range, and so on. Second was to use which type of graph. And this both we had covered in the previous session. And the third purpose for understanding the level of measurement was to decide which test to use. And I'm sure this is the question majority of you might be having it, that for your data, which test is best suited? Whether I should go for a chi-square test or an F test or a T test or an ANOVA, when to go for ANOVA, when not to go for ANOVA, and whatnot. So there are many questions related to hypothesis testing. But one thing I'm sure that you all are clear that every research paper, majority cases, or every research project reports should have a hypothesis. Because when the objective of your research project can be justified, can be verified using a hypothesis testing only. So that way, this becomes a very, very important point of going along with why we are doing with this hypothesis testing. So let me go with the basic concepts of it, very basic concepts of it, that mainly statistics can be classified into two: descriptive, where we describe the data, where we present the data, where we summarize the data. So that is called descriptive statistics, in which we find out mean, median, mode, we find out graphs and all, we form the tables and all. So that is all descriptive. And the other is inferential. Inferential comes from the word infer. So what to infer? Infer about the population. Based on what? Based on the sample that is collected. So to infer about the population based on the sample that is collected, we go for inferential statistics. And we know that in majority of the cases, majority of our study, we go for a sample study only. Recently, Pandya madam was talking about that when you want to check about an IQ, when you want to design an instrument about the IQ of your 10th standard or 12th standard students, you need to have a large sample size. And so ultimately, it is what you want to have an instrument which is applicable for IQ, or to measure an IQ of, say, 10 standard students. So if I want to take an IQ of 10 standard student, I want to measure the instrument, or I want to prepare an instrument, or I want to develop a measure for it, I have to go to each and every individual of 10 standard, whichever board, across the board, I have to take it. And if I do that, then it is called a population study. And we know it is not feasible. It is not practical. So what we do, we take a sample. We study the sample. Whatever results we get over here, we say that results will be same for the population. So we are inferring the results of the population from the sample. And so this is called inferential statistics. And there is a whole branch of statistics, which is inferential statistics. And there are books and books, volumes and volumes of only inferential statistics. Okay, this is what we have done. Now in inferential statistics, there are mainly two parts: estimation of parameters and testing of statistical hypothesis. I hope you remember what are parameters. No? Okay. Parameters are the calculations done on the population observations. Parameters are the calculations or the measures calculated on the population observations are called parameters. And the measures calculated on the sample observations are called statistics. So if I ask a very basic question, mean. Honestly tell me, when I say mean, which notation strikes first? If I say mean, yeah, Subhashini ma'am, you are right. Immediately what strikes is what? X bar. But that is actually based on the sample observation. So that is the statistic. And the population mean, it is mu, denoted by mu. So normally we have to actually find out mu. We don't know mu. So we find out X bar and we say that will be the answer for the mu. That is called estimation of parameter. That means we wanted a value of mu, we are calculating X bar, and on that we estimate that will be the same value for the population parameter. So that is called estimation of parameter. Okay, so we go further. If I say standard deviation, same way, if I talk about standard deviation, I'm sure, yeah, it is, what is the notation? Sigma. Very good. But sigma, again, when I say standard deviation, first thing that strikes in the mind is S. That is for statistic, that is for the sample. That is for sample. For population, Subhashin ma'am, you have rightly said it is called sigma. By the way, don't confuse, because in many of the workshops that I take, people feel that this is sigma, this is not sigma. But actually this is also sigma and this is also sigma. Like in English alphabets, this is capital A, this is small a. In Greek, this is capital sigma and this is small sigma. This is used for summation and this is used for standard deviation of parameter of the population. Right? If I talk about proportion, then proportion is just like a percentage. So for the parameter or for the population, it will be capital P, and for the sample, it will be small p. Correlation coefficient, immediately what strikes is R. But for the population, it is denoted by rho, R-H-O. So the point I'm now trying to convey is we are actually calculating, we are actually needing these values. We are actually needing a population value, but it is not feasible. It is not viable. So what we do, we go for a sample study. Whatever results we get, we say, okay, that is applicable to the population parameter. So that is called estimation of parameter. Getting the idea? That is estimation of parameter. Right now, we are not dealing into this because our focus is on the second part. What is the second part? Testing of statistical hypothesis. Testing of statistical hypothesis. That is the second part, that when we estimate X bar as mu, can this estimation be checked, verified, whether it can be taken or not? That process, that steps of checking whether our hypothesis, whether our assumption is true or not, that is done by testing of hypothesis. That is done by testing of hypothesis. So what is testing of hypothesis? It is checking our assumption, because as a hypothesis is nothing else but our assumption. Assumptions about population parameter, that is called hypothesis. Okay, this we can skip right now. Yeah. What is, as I said, hypothesis is nothing else but an assumption or any logical statement about the parameter of the population. If I ask you that what is the recovery rate in this new variant of virus? What is the recovery rate? Or the fatality rate? So, okay, what is the fatality rate in new Omicron? The virus that is new in this case. Then I may say that the fatality rate is probably 1%. So that is 0.01. So this becomes my hypothesis, my assumption. Okay. Some of you have said, yeah, Subhasini ma'am, you said 1%, great. Okay. If someone else may be saying that it is 3%, then the hypothesis for that person comes to 3. So proportion that comes to 3%. If I ask you, what is the average income of individuals in Mumbai? Average income of individuals in Mumbai. If that is my question, right? Then I may have okay, Sumaji ma'am is saying that it is 20,000. I say average income of staying in Mumbai is say 30,000. Average. So mu is equal to 30,000. That becomes my hypothesis. Subhasini ma'am said 20,000. Okay, so that is 20,000 over here. So that is her hypothesis. Okay. Chitra ma'am is saying that it may be, again, a mean, the average means it is mean. So she might be saying it is 35,000. So that is the hypothesis. So any assumption about the population value, population parameter is called the hypothesis. And then what is null hypothesis, which is denoted by H0? Null hypothesis is denoted by H0. So again, null hypothesis is nothing else, but it is a general statement about the population parameter, or between the two population parameters, or between more than two population parameters. It can be anything, but it is ultimately a general statement about the population parameter. Or in other words, in certain books, you will find this also, that an assumption that we feel it is true, but still we want to check. As I said, I want that electric vehicles, say four-wheelers particularly, what is the mileage that they give? Average mileage of electric vehicles. Suppose my guess, my assumption that average mileage is 65. Average mileage is 65. Okay, one time if you charge, it may run up to 65 kilometers or 165 kilometers, depending on the battery and depending on the charging speed you have it. Suppose I am making a very rough guess, it is 65, right? Then that becomes my null hypothesis, which is denoted by H0. Null means 0. Hypothesis, so it is H. So that is called null hypothesis. In all Indian author books, you will find the null hypothesis to be simple. Simple means having equal to sign. But it is not necessary that always it will be equal to. In foreign author books, you may find it out as greater than or equal to, or less than or equal to also. But we will focus right now, as you are doing it for the first time, we'll focus only on this. No doubt conclusions for both will be the same. But this will confuse you initially. So we are avoiding this composite hypothesis. But the same problem, we can frame null hypothesis, which is simple also and which can be composite also. So if I say simple hypothesis means when we put equal to sign, that 1% is the fatality rate, then this becomes simple. If I make that at least, or it is not more than 1%. If I make a statement, directional, yeah, you can say, Subhash, no, it is directional, that is right, because it goes to a particular direction, right side or left side, that it can be taken. But that will be, actually direction is decided based on the alternative hypothesis, not based on the null hypothesis. But if I make my statement, my null hypothesis that the fatality rate in this new variant is not more than 1%, then my P will be less than or equal to 1%. This is composite hypothesis. Okay, so your hypothesis can be equal to, or it can be greater than or equal to, or less than or equal to. Composite hypothesis will never have only equal to sign. It is not possible. Only less than, it is not possible. It should be greater than or equal to, or it should be less than or equal to. Equal to is compulsory, there it should be there. Then only we can do the hypothesis test. Okay, now what is complementary or alternative hypothesis? Alternative hypothesis is complementary to the null. Now in computer, we know there is only two codes, 0 and 1. So if 0 is null, complementary to 0 will be what? 1. And so alternative hypothesis is denoted by H1. I'll go in detail about this all. Let me take an example to clarify this. If I make a statement, like actually Gujarat is said, I'm from Gujarat, so I would say Gujarat is considered to be the capital of diabetes. You might have heard about it. Gujarat is considered to be the capital of diabetes. That means there are more number of diabetic patients in Gujarat compared to any other states. So my statement, I'm making a statement, right? I'm making a statement that there are 37% of Gujaratis are diabetic. So my proportion of diabetic patients is 0.37. Right? I'm making a statement that 37% of Gujaratis are diabetic. I'm making a statement like 6. So P is equal to, percentage means proportion. So P is equal to 0.37. That is my null hypothesis. Now you tell me, listen to the words carefully. Now you tell me in how many ways you can oppose my statement, in how many ways you can differ to my statement. Just write down in the chat box, in how many ways you will differ to my statement. Super. Divya ma'am, Suhasini ma'am. Okay. Perfect. Or anyone else? Less than, more than. Okay. Yeah. So some of you may differ to me, like saying that 0.37, it will be more than 0.37. So that means you can differ to my statement saying it will be more than 37. Or some may say it is not 0.37. I feel it is less than 0.37. So again, you are differing to my statement. And some person playing a very safe game will say it will not be 37. It will not be 37. So there are three ways to negate the null hypothesis. There are in three different ways you can negate your null hypothesis. Yeah, Dr. Swapna, you are right. Lakshmi Prabha, you are right. I think, yeah, I think this Vinita ma'am, you are also right. So I think you are getting the concept about it. There are three ways to negate the null hypothesis. And that is why you can see in the alternative hypothesis, there are three options: not equal to, greater than, or it can be less than. So the point again, greater than means we are moving only towards right. So this is called right-sided one-tailed test. Why it is called right-sided one-tailed test? Because this is say mu0, then we are going only on one side. So this is one tail, but it is on the right hand side. Same way, here suppose it is mu0, we are moving towards only left side. So this is called one tail only, but it is left-sided. And when I say not equal to mu0, that means it can go on both sides. It can go on both sides. So this is called two tail. Now, right now, if you don't differentiate right tail and left tail, it's okay. You simply have to differentiate this, that whether it is one tail or two tail. So just remember this way, not equal to means it is a two tail test, greater than or less than, it is a one tail test. That is alternative hypothesis. And how to decide this? It is actually based on the problem. Based on the problem that you are dealing with, based on the hypothesis that you have framed, based on the objective of the problem, then of the research problem rather, you have to decide whether it will be greater than or equal to, or less than or equal to, or not equal. That will be decided based on the problem. I'll take an example just to clarify this, because I feel, see, the most important part in this steps of hypothesis is null and alternative. H0 and H1 are the most important part. Rest all software will do it for you. Whichever software you're using it, that it will be done. Main part is to decide your null and you to decide your alternative hypothesis. Let me clarify this. If I say that Philips company, they are manufacturing LED tube lights or LED lights. So the Philips company is claiming, they claim that an average life of the lights they manufacture is 600 hours. What is their claim? That average life they manufacture is 600 hours. Okay, so my null hypothesis will be the claim that is mu equal to 600. What was the claim of a company? Claim of a company was 600. We are also saying it is 600, means claim is tenable or claim is true. What will be opposite to this? Because what is complementary and what is alternative? Complementary to the null. So what is complementary statement to claim is true? Here it will be claim is false. So when you will say that a Philips company is wrong, will you complain? Will you complain that if the Philips, the bulb that you're using it, if it is working for 800 hours, would we go and complain to the Philips company that your claim is wrong? No. So when we will complain that a claim is wrong? Okay, less than, Sridevi is perfect. It is less than. Okay, good. So this means mu less than 600, mu less than 600 becomes our alternative hypothesis. So it is a one-tailed. Getting the idea? I'll take one more because I would focus more on this because this is the most important part. Say in the multiplex, there are vending machines for the cold drinks, soft drinks now, whether it is Pepsi or Coke or Thumbs Up, whatever it might be, there are vending machines. And they give in glass. Initially it was in bottles, but because of that MRP issue, they are now giving in glasses. So one glass of cold drink or soft drinks, we can say, it was designed to fill up 300 ml. So when you go to the mall, when you go to the multiplex also, there are vending machines. The person taking charge of it just has to press the button, automatically 300 ml or whatever it is designed for, it will be filled. Suppose I'm talking about a machine which is designed for 300 ml of glass, 300 ml of cold drink. So after few instances, the manager, okay, the manager or the person who has taken the franchise or who is dealing with the food park of that particular multiplex, complained to the company that the machine is not working properly. Machine is not working properly. This is the complaint that he has made. Now we want to check whether it is true or not. Okay, suppose we are the owner of the company and we want to check whether the complaint of the manager is valid or not. So what we'll do, we'll go over there, we'll randomly say fill up 50 glasses, we'll find out what is an average ml that is filled in the glass, and based on that we'll decide whether the claim of the manager or whether the machine is working properly or it is not working properly. We will never check with one glass because it may be that after taking an average of it, we will be having more precise data-based, data-driven decision. So here also it is the same thing. So here we will say H0, it is always equal to, as I said, null hypothesis. We will go for simple null hypothesis, will not go for composite, right? We'll go for a simple null hypothesis. So I'm saying mu is equal to 300 ml. If I say mu is equal to 300 ml, that means machine is working properly. It was designed for how much? 300 ml. How much I have written? 300 ml. So that means machine is working properly. H1, complementary. So what is a complementary statement to this? Machine is not working properly. When we will say that a machine, because we are the owner of a company, right? When we will say that a machine is not working properly, less than, okay, Sridevi, it can be less than also, it can be more than also. If the machine gives the cold drink less than 300 ml, then also it is not working properly. If it is giving more than 300 ml also, then also it is not working properly, right? So it can have both the options. It is either it is greater than or less than, we can say machine is not working properly. So less than or greater than, both options are there. In that case, it will be mu not equal to 300 ml. So this is a two-tailed test. So this is how the whole thing can be decided. Okay, I'll take one more. Yeah, Sanjay ji, you are saying, but more than will be a loss. That is true. More than is a loss, but it is machine is not working properly. Right now, we are not taking the customer side or we are not taking the franchise side. We are the owner of a company and we are solving a complaint that a machine is working properly or it is not working properly. Yeah, defect with the machine we are talking about, whether the machine is defective or not. Sanjay ji, your problem can be dealt in a different way. The question that you are having it. Suppose the same thing, same problem. See, I'm changing the question now. Glass vending machine, there should be 300 ml. It was designed for 300 ml. But the manager is now receiving complaint from the customers that manager is receiving the complaint from the customers that they are not getting 300 ml. The problem is the same. It is the same vending machine. It is about the glass of it. But now who is complaining? The customer is complaining that the machine is not giving, or the customer is complaining that we are not getting 300 ml. Okay. So here it starts with this way again. Mu is equal to 300 only. H0 will always be equal to. When say mu is equal to 300, that means customers complain is not valid. Customer is wrong. Customer was complaining that we are not getting 300 ml. So, and if we write down mu is equal to 300, that means they are getting 300 ml. So customer's complaint is wrong. So what will be alternative hypothesis here? Customer complaint is valid. When we will say that the customer's complaint is valid, Sanjay, see now your problem that when we will say that a customer's complaint is valid, it is less than 300 ml. Will the customer complain if they get more than 300 ml? Practically, just think about it. Will we complain? No. So that is why we say here the same, the problem style was same, but the approach, the problem, the direction of the problem was different. I'll take one more, just last one, and then we'll move further because I have to take the different taste also today. Say Yera Glass Company, or we can say Saint Globin, whatever you like, whichever company you like. Suppose it is Yera Glass Company who are into manufacturing the glass bottles. The company claims that only 1% of their glassware will be defective. Only 1% of their glassware will be defective. Now we want to be the distributor of Yera. We want to be the distributor of Yera, and we want to check this claim. Is this tall claim, or is this claim true or justified or not? Right? So we want to be the dealer or the distributor. So what we'll do, we'll randomly take different bottles from the different areas or the different production that Yera has done. Right? So I'll start with my null hypothesis. Because it is percentage, so it is proportion. So P is equal to 1% means 0.01. What was the claim of a Yera company? That there will be 1% defective. So we are saying 1% defective means claim is justified. The company, whatever they are claiming it, the Yera company, that it is 1%, it is justified. What will be opposite to this? Claim is not justified. The company is wrong in their claim. Now you tell me what will be the relationship between these two. Super, great. Yeah, Divya ji, Priyanka ji, Sohasini ji, Dr. Swapna, yeah, perfect. Yo, Vinita ji, perfect. Priyanka ji, perfect. Divya, Sridevi ji, perfect. Okay. Why it will be this? Now think practically. That company was claiming 1% defective. Now we as a dealer, we took a sample and we got 0.5% defective only. Will we say Yera is wrong? It is a bogus company. It is claiming 1%, but we are getting less defective than that. No. So when we will say that a Yera company is wrong, when we get P greater than 0.01. So this is a one-tail test. This is how one tail and two tail is decided. I hope you all are with me. Yes, Sanjay sir, Subhashini ji, perfect. Kandambari ji, now it is clear to you. Perfect. Chitra ji, Aruna ji, Kandambari ma'am. Okay, perfect. So this is how null and alternative hypothesis will be decided. Now there is more technicality into this. There are more terminology that we have to use it. Type 1 and type 2 error. Okay, let me go with a little bit. I'll go a little bit and touch a little bit about this. What is type 1 and type 2 error? I'll explain it with a figure. Okay, I'll do it over here. See, for example, your hypothesis is true. Your null hypothesis can be true or it can be false. There are only two options. Your assumption can be true or it can be false. And the hypothesis procedure can either accept your null hypothesis or it can reject the null hypothesis. Right? Now, if the hypothesis is true and we accept it, that means it is a correct decision. Hypothesis was true and our test procedure accepted it, so that means it is a correct decision. No issue with this. This is a correct decision. If the hypothesis was false and we reject it, again, it was wrong and we rejected it. So again, it is a correct decision. The problem starts when there is a cross connection. What is that? If it is true, my hypothesis was true. My hypothesis was true, but due to some reason it got rejected. Due to the process, it got rejected. So it was hypothesis was correctly designed, but due to my test procedure, due to the sample that I've selected, it got rejected. This is called your type 1 error. It is an error of hypothesis testing. So what is type 1 error? Type 1 error is rejecting a true hypothesis. Same way, if it is false and it is getting accepted, then it is also an error which is called type 2 error. And the probability of type 1 error is generated by alpha and probability of type 2 error is generated by beta. You can consider this as, if you're still finding it difficult to understand, I'll make it more relative. Say there is a manufacturing unit. You are manufacturing, say, mobiles. So mobile, once you manufacture, it can be either of a good quality or it can be of a bad quality. Either the market will accept your mobile or it will reject your mobile. If good mobile is accepted, okay, it is a correct decision. If a bad mobile is rejected, it is a correct decision. Getting it now. Now see the problem. Mobile was good, but due to some reason, market has not accepted it. Due to some reason, mobile was good, but due to some reason, market has not accepted it. Who will be at loss? Producer. So this is called producer's risk. It is also alpha. It is the same thing. Type 1 error. Same way, if a bad lot is accepted into the market because of the marketing strategy, because of the advertisement, whatever we say, but the bad lot, bad mobile was accepted in the market. Who is going to suffer? One who buys it. That means the consumer. So this is called the consumer's risk. And the probability of consumer risk is beta. It is same as type 2 error. Biologically, we say it is true positive and false negative and all that. So that also is another angle to understand it in medical terms, in pharmaceutical terms, or in biological science terms. We can say it in this way. But this is more of a manufacturing side. And this is more of a statistical side. And for medical terminology, we will say it is in this way. It is this. Type 1. So this is false positive. And this is false negative. Type 2 error. Okay. I hope you are getting it. Type 1 and type 2 error. Why it is taken care of, what should be the value of alpha and beta, how it is to be decided. I think that is a whole different branch. Right now, we don't have time that much to discuss about it. But a simple term is we have to balance type 1 and type 2 error. And depending on the problem, we have to focus on type 1 or type 2 also. We'll fix out one and we'll try to minimize the others. So generally here, right now, we'll fix up alpha value. This alpha value will be fixed up. What is this? It gives you, it says that in terms of hypothesis testing, what does it say? It says that 100 times, suppose I say alpha is 1%. What does it say? 100 times, if I do this process of hypothesis testing, one time I may be wrong in my decision. One time I may be wrong in my decision. That is called level of significance. And it is fixed. This is fixed beforehand. Before a survey starts, before an experiment starts, before a project starts, before an experiment starts, alpha is fixed up. By what? By the sponsoring agency, by the company, it is fixed. Yeah, Tata Nano. Yeah, it is a producer's risk. That's true. It was of a good quality, but due to some reason, because of the wrong positioning of the product, it got rejected. Okay. Critical region, I think right now it would be a little bit heavy for you to understand the critical region. Power of the test is 1 minus beta. Is okay? Yeah, this is important for you. Now, ideally, any hypothesis testing, we go with the test statistics. You might have heard about Z test. You might have heard about T test. You might have heard about F test. You might have heard about chi-square test and whatnot. There are many, these are different test statistics. So depending on the problem, depending on your purpose, depending on your objective, different tests are used. So what was happening before the software came into the picture? We statisticians, but still right now also we do it manually. So what we do, we calculate Z and compare with its stable value. We compare T calculated with its stable value for accepting or rejecting it. Same way F and so. So we were comparing the table values with the calculated values that we have it. So the problem was every time when we use a new different statistics, we need a new table to compare. Now this becomes difficult for a non-statistician, right? For every time, because you need a different table to compare and conclude. And so now in the softwares, they are not giving this, they give actually, but the conclusion is not only based on this, it is based on the p-value. P-value is nothing else with the probability that the test statistics would be extreme. Okay, would be extreme or more extreme than the observed statistics. Now that would be a difficult statement to understand for you. I would say simply remember, smaller value of P means the stronger evidence against hypothesis, null hypothesis. Okay, I'll make it still simple, still simpler. If I say the same problem, H0 was mu equal to 300, machine is working properly, machine is not working properly, right? I took a sample of 100 glasses, right? And my average was 290 with a standard deviation of 20 ml. I want to check now whether H0 is accepted, that is machine is working properly, or machine is not working properly. So I'll go for a T test and Z test and whatnot. But ultimately what we'll do is we'll find out the p-value. The software will give you the p-value. It will give you the p-value. If this p-value is less than or equal to alpha, understand this very carefully. This will be used throughout the hypothesis testing. And probably it will be used everywhere in regression, correlation, ANOVA, non-parametric test, and all hypothesis testing. This logic will be used. If P is less than or equal to alpha, what is alpha? Generally, we take it as 5%. In industry, it is 1%, 5%, or 10%. These are the alpha values that normally are taken into industry. If P is less than or equal to alpha, then we say H0 is rejected. This is rejected. And that means this is accepted. That means machine is not working properly. If your p-value is greater than alpha, then H0 is accepted. H0 is accepted means this one. That means machine is working properly. So things becomes very easy now. You don't have to check the table value of T. You don't have to check the table value of F. You don't have to look the value of F. You don't have to remember the formula for F. You don't have to remember the formula for T also. Straight away, you only see the p-value. You only see the p-value. and compare with your alpha. Generally, it is 0.05 only. Compare with 0.05. If P is less than 0.05, less than means rejected. H0 is rejected. And greater than means it will be X. This is how the P value works. Okay. We'll take in the sums. Don't worry. Now, these are the steps. Whatever hypothesis testing we use, the steps remains the same. Step 1, null hypothesis, means H0. Step 2, alternative hypothesis, H1. Step 3, checking the assumptions, which normally no one checks. No one checks. And that is why the problem starts that without assumption checking, you use a particular test and you are getting a result, but still that is not acceptable for the good research journals or good research paper, because you have never checked the assumptions. So third step, that is why purposefully I have written over here, you have to have checked the assumptions of that test. Then software will give you the test statistics. Softwares are very easy. If you put in the data, you will get a p-value, right? So it will give you the p-value. Whether it is applicable or not, that we have to decide. That is based on assumption, and that is based on which test to use. And then the conclusion. If P is less than or equal to alpha, reject. Greater than alpha means fail to reject means accept. So this way, we will be following 5 steps for all the hypothesis testing. And I have a habit of doing these steps only, because when you do your own analysis, it should not be haphazard. It should be step by step. That is why if you do the step-by-step process, you will never go wrong. Your hypothesis testing will be up to date, acceptable in any good research journal if you get the appropriate results. So step 1, null. Step 2, alternative. Step 3, assumptions. Step 4, the table value or the p-value. And step 5 is the conclusion. These 5 steps will follow. Just remember this. If you want, you can take a screenshot. No doubt it is available in my blog also. But right now, for the reference, if you want, you can keep this as a screenshot. Now, these are the some test. I'm using the word some test. There is a long list, but these are some test. Single mean test, 2 mean test, single proportion, 2 proportion, single standard deviation, 2 standard deviation, more than 2 means, more than 2 standard deviation, more than 2 proportions, for non-normal, for correlation, for regression. There are on and on and on. There are many tests that you can go along, and it can be used for your particular problem. But the question comes, the big question is when, which test to use? Am I right? This is the question. So next slide is for that. So now pay attention, just like what we did in what? We did it in summary statistics, we did it in graph also. Same way, I'm giving you one slide that would include everything, which test to use when. Okay, we'll start it in this way. And any question regarding to this, we'll take it at a later stage, because now I think it is almost 6:20 and I have to finish in 40-45 minutes. So understand this part very carefully. Amit ji, alpha and level of significance are same actually. Level of significance is the risk that ultimately, in other words, we can say it is a risk that a sponsor is ready to take. Why it is a risk? Because when I say 1% alpha, that means 100 times if you do this process, one time you may go with a wrong decision. So that is a risk. That is a loss to the company. So how much risk they are ready to take, that is the value of alpha, which the sponsor has to decide beforehand. Okay. Now just recollect one thing before I go further. Level of measurement. Your data can be categorical. What was the other? Let me check. What was the other? Good, Subhasini. Anyone else? I'll go with that. Okay, parametric or non-parametric, I'll go with that. Great. Okay. The number means it is a scale. Good. So that means you can recollect what I have done before. So your level of measurement, your variable can be either categorical or scale. Now we will decide based on that only. If you recollect further, in scale, your data can be normal or it cannot be normal. That means skewed data. If you recollect, if your data is scale, if it is normal, then only we were going for mean. I hope you recollect. If your data is scale, but it is not normal, which central tendency to use? Which central tendency? Yes, it was median. You to go for a median. Right? Okay, with this basics, we'll go now with deciding the test. Suppose your data is scale. Your data is scale. And it is following a normal distribution. It meets the normal assumption. So data is scale and it is having a normal distribution also. That means now which can be the parameter? Parameter can be mean, and we can use standard deviation also. We can use mean and we can use standard deviation because the data is scale and we can go for, and it is following a normal distribution also. Suppose we want, our objective is to check the average, whether the average income of individuals staying in Chennai is more or whether the individual staying in Calcutta is more. I want to compare the means, right? I want to compare the average income. I want to compare average height. I want to compare the average marks. I want to compare the average IQ. That means if I want to compare the means for one sample, which test to use? It is a t-test. One sample t-test we have to go for. For two samples, it will be two sample t-test we have to go. But for more than two samples, we have to go for ANOVA. Why I'm clarifying this? Because I have seen many of in many of the workshops, the participants are asking when to use ANOVA. So ANOVA, when to use, first of all, check whether your data is scale and it meets the normality, number one. Number two, your objective is to compare the average. And if there are more than two samples taken, then we have to go for ANOVA. If there are only two samples taken, then we have to go for a two sample t-test or one sample t-test. Okay, there are a few comments. Yeah, F-test is different. F-test is different. I'll go with that. F-test is different. Now, if your objective is to compare, or if your objective is the variability, that means the standard deviation. So for one sample, if you want to check the standard deviation, then we have to go for a chi-square test. For two samples, if you want to compare the standard deviation, you have to go for F-test. So much remember the point that you were talking about. For two samples, if you want to check the standard deviations, whether there is, if I want to compare, say, Ahmedabad and say Delhi, I want to compare where there is more variability in the income. Where there is more variability in the income, whether Ahmedabad has more variability in the income or Delhi has more variability in the income. In that case, that means I want to do for the standard deviation and there are two samples taken. So I have to go for F-test. So F-test is used to check whether the two variances are equal or not. And if you want to compare standard deviation for more than two samples, then we have to go for a Bartlett test. Right? The second part now, if it is scale, but it does not follow normal. Possible, your data is not normal. Then you can always go for median only. You cannot go for mean, that we have done it before. So you can go for median. And here it comes to the point that some of you were asking, it is a non-parametric test. This all are parametric tests. So if it is not normal, then there are two ways. Okay, I'll clarify that also. There are two ways. Either take a transformation of your variable and convert it into normal. That means, I'll explain this way. If your data is like this, so it is not a normal distribution. So either you go for this test, that is a non-parametric test, or you transform this by taking log and convert it into normal. and then go for this test. So depending on what you want to do it, generally, it is to go for a non-parametric is better, because transformations, there are many. It can be square, it can be log, it can be square root. Depending what your problem and the shape of the variable looks like, accordingly, you have to take a transformation. You have to take a reciprocal also. So there are other ways to do it. But if your data, in short right now, if your data is scale but not normal, go for median. In that case, for one sample, you can go with a Wilcoxon sign test. For two samples, it will be Mann-Whitney. So two sample t-test is same as Mann-Whitney u-test in non-parametric. ANOVA, it is same as Kruskal-Wallis test. Kruskal-Wallis test. That means if you want to compare median for more than two samples, then it is Kruskal-Wallis. Now the second part comes. Okay, this was about the scale, whether it is normal or not normal. If it is categorical, then what? If it is categorical, then we have to go for a proportion test. So this will be single proportion test, two proportion test, and binomial analysis of means test. So this slide includes every test that you have to utilize. Lakshmi ji, Dr. Lakshmi Srinivasan, you are asking when to use Z test. A good question. Actually, I'll go with this now. Z test can be used, or we can say Z test and T test, softwares give the same answer. So that is why right now I've used only T test over here. Otherwise, Z and T are different, but software will give you the same answer. The reason is, as the sample size increases, T distribution tends to Z distribution. T distribution tends to a normal distribution, and so the results will be same if the sample size is small. If the sample size is less, as such, we have to go for a T test only. So ideally, if I go with the very technical part, when population standard deviation is known or is given, then only you have to go for Z test. When population standard deviation is given, then only we have to go for a Z test, and generally this is not known. Population standard deviation is not known to us. If it is known, fine, we can use for a Z test. But even if you use T test, your answer will be same as Z if you use softwares for it, because software automatically, for a larger sample size, T tends to Z test. So answer will be same. That is why in this slide, I have not included Z test, because it is one and the same thing in case of software. Okay, perfect. Easy. You can take a screenshot if you want. Then we'll go further. Now we are actually starting with a different test. Today, I'll be covering with this 1, 2, and paired T test, which I'm sure many of you are right now also using it, paired T test. So these are the three. So we'll be using this 3 tests now. And I'll be showing you step by step everything with the actual data and screenshot also. So now we are starting with the first test. This is test for single mean. Test for single mean. Now understand this part. If I want to use this test, your data should be what? It should be scale. Second, it should be normally distributed. Then only I can use this. But no one is checking this. We will do that. And how it is done in SPSS, that also I'll explain. So that is why if you see my steps now, this you will not find in any book. My step says, first step is H0, second step is H1, third step is assumption checking. How to check, what are the assumptions? That your data is normally distributed and this variance is unknown. Because if it is known, as I said, if it is known, you have to go for a Z test. Now, how to know whether this variance is given or not? If you read the problem, you will be able to know whether sigma square is known or not, or standard deviation is given, population standard deviation is given or not. So this is no need to check. But the normality can be checked by 2 things. Shapiro-Wilk test. It can be also Kolmogorov-Smirnov also we can take it. But Shapiro will test, or graphical if you want to check, it can be with the QQ plot, quantile plot. We'll do both. So don't worry. Right? So that is step 3. Step 4, test statistics and the p-value. Step 5, conclusion. P less than alpha, we reject, greater than, we accept. Okay? But the important part, you will not find this, so we will do this part, which is very important. Now we are starting with a problem. Selvi, ready? So next half an hour will be exactly SPSS, and we will be working on it. Then I'll send my data to Shailila ma'am. Whatever I'm explaining today, that actual data will be given across to you so that you can compare this slide, what output I'm getting it, and you can do it your own also. Nothing is trademarked. So you can use my presentation also, you can use my data also, because nothing secret about it. Okay, now the problem is, based on the field experiment, a new variety of green gram is expected to give an average yield of 12 quintals per hectare. That means there is a new type of seed that agriculture university or maybe the government department has developed, and it is giving more yield. Okay, and the yield is 12 quintals per hectare. That was a claim, that was a statement given. Based on the experiment, a new variety of game is expected to give 12. Now we want to check this. What we'll do, a variety was tested on 10 randomly selected farmers' field. So now that seed was grown in 10 randomly selected fields, and we were getting this quintals per hectare. So this is the output, this is the yield per quintals per hectare. We want to check, do the results confirm the expectation? Do the result says that it is 12 quintal, and do this sample confirm the results? Okay, this is what we have to do it. Don't forget the steps, because my whole presentation will follow the same steps. I'll just recollect. Step 1, H0. Step 2, H1. Step 3, assumptions. Step 4, test statistics and p-value. Step 5, conclusion. Same steps we will follow. Right? The first step, now I'll make my null hypothesis. Now recollect, what was your null hypothesis always taken? First of all, your null hypothesis, you focus, what is the question? Average. Average means mu. Right? I want to check whether average is what? How much? 12 quintals. So mu is equal to 12 quintals. We will always write down equal to. Right? That means if I say mu equal to 12, what was expected? Expected was also 12. That means results confirm expectation. What was the expectation? 12. What have I written? 12. That means results confirm the expectation. What will be H1? Negation of this. That means results does not or do not confirm the expectation. That means what? Mu is not 12. So this is a two-tailed test. Simple, very simple part. Focus on the question. What is the question? Does the result confirm the expectation? So what we'll say, it is confirming or it is not confirming. If it is equal to 12, we'll say it confirms. If it is not equal to 12, we'll say it is not confirmed. Average yield is not 12 quintal. The result does not confirm. So this is a two-tailed test. So step 1, step 2 is done. Yeah, step 1, step 2 done. Okay, what is the third step? Third step, assumption. And what is our assumption? That sigma square is not known. Is sigma square population variance given over here somewhere? Sigma square? No. So one assumption is checked. What is the second assumption? That our data follows a normal distribution. How to check now? How to check the normality? Okay, I'll go with now Excel file, my data file also. It is a green gram. This is an SPSS file I'm opening up. By the way, I've been teaching statistics since long, probably 1996. But to your surprise, first time I heard the P statement, P value that I'm teaching you right now. When I did my course of SPSS from CMC Value, I learned SPSS in 2004 from CMC Value. First time I came to know the word P. What is P statistics? What is the P value? How to calculate that? Before that, I had done my PhD in statistics, but no one were using softwares for it. We all used to do manually. But then this problem of simplifying the data analysis, because manually it was taking a lot of time. So now the softwares, SPSS and all, in 2004, when I learned from CMC Value, Dr. Jesilen was there. Dr. Jesilen, I don't know whether he's still with the same department or not, but Dr. Jesilen taught us in a summer projects about how to use SPSS, how to use P value and all. Okay, this is the data. Yield of crop, you can see 14.3, 12.6. It is the same data that I have utilized over here. Here it is 14.3, 12.6, 13.7, and so on. So I have entered the data in SPSS, or you can even, now Raju sir might have explained how to load the data in SPSS. That also might have explained. So that is not an issue. Now I want to check whether the data, so my third step is assumption checking. And what is my assumption? To check whether it is normally distributed or not. I'll go with over here in descriptive statistics. Understand the steps. You will get that in my presentation also. So in analyze, in descriptive statistics, go with explore. If you click on explore, a new window will open. And it will show you your variable. What is my variable? Yield. Yield is my variable. Click on this and select in the dependent list. Select in the dependent list. So that means I want to now work with my decision variable, that is yield. Why we have to select? Because your data may have more than one column also. You may have yield, you may have fertilizer, you may have pesticides, you may have irrigation facility and whatnot. But I want to focus right now on yield. So I'm selecting yield as my dependent variable. Then I want to check the normality. So go into the plots. Here it is plots. Go into the plots. Here you will see the normality plot with test. Here it is. Check. It is a checkbox. So check on that. Right? No need to check out others. Check on the normality plot, because now we are dealing with right now the third step, assumption checking. So normality test, continue. Here it is, continue. You will get the result. This is the result. And here the result I have shown over here. This is a test for normality. You will get it as Kolmogorov and you will be getting the two things. Okay, who has raised the question? Gagnavel, Dr. P. Gagnavel. What is your question? Okay, I'll go further. As I said, in plots, you have to in plot, click on this normality plot. This is a normality plot where we have checked box. We have clicked on that and we are getting this result. It is the same result. I have taken it on the slide. What we have to do is, you can check your normality with Kolmogorov-Smirnov also or Shapiro-Wilk, but this is proven. So we'll go with this. So here what we are making an assumption. So my hypothesis over here, H0 will be data is normal. An alternative is data is not normal. We are making a statement hypothesis that data is normal and data is not normal. What is this in Shapiro-Wilk test? This is the p-value. Significant value means it is a p-value. So what is your p-value? 0.891. 0.891 compare with 0.05. So 0.891 is greater than 0.05. Greater means what? H0 is accepted. Greater means accepted. H0 is accepted. What is H0? Data is normal. So that means yield of green gram is normally distributed. So now I'm getting a signal, a positive signal, a green signal that I can go for a t-test. If this was not normal, I cannot go for t-test. I have to go for a non-parametric test. I hope the point is clear. Great. So third step is done. Third step is done. I repeat my point again, how to go for it. When you go for, I'm putting up the SPSS now again. This is the SPSS. I'm going it again. In analyze, descriptive, explore. In explore, select this, go for plots. In plots, checkbox the normality plot, you will get the result. Have I made the things clear? Great. So now third step is done. What was your third step? Assumption checking. What is your fourth step now? Taste statistics and the p-value. Okay, so now I have to go with the taste statistics. That means I want to go perform. What I want to perform? t-test. Because now they are given the signal that data is scale. Because it is yield of crops, it is a scale. And second, it is normally distributed. So now I can go for a t-test. Okay, so now I'll go with analyze. Compare means, in that you can see in compare means it is one sample t-test. I'll click on one sample t-test. I'll select my decision variable over here. Now you see over here taste value. This taste value is nothing else but your mu. It is your mu value. What was your mu? What was your mu? Here you can see null hypothesis. What was the mu value? 12. Mu value was 12. So I'll put 12 over here. My test value is 12. That's it. Okay. Test is done. No need for the formula and no need to remember the how to calculate t and all. The t test is ready. So the table that you will be getting over here is this. Yeah. This is what I have shown you. This is the table, output table that you'll be getting it. And this is okay. There were 10 observations. The mean of that 10 observation is 12.630. Mean of standard or standard deviation is this. Standard error of mean. Standard error of mean is nothing else but you don't need it actually. But this is sigma upon root n. If you take 1.085 divided by root of 10, you will get 0.3432. It's okay because that is used in calculating the t value. If you go with the formula for t, it is actually x bar minus mu divided by s upon root of n and so on. So this denominator is nothing else but standard error. So I'm not going into that how to do it manually. But now what you do check for is checking the significant value. This is your significance means p value. So my p value, step 5, is 0.100. That is greater than 0.05. Now understand this part, why it was important and why was I emphasizing on null and alternative. What was our null hypothesis? Mu equal to 12. What was my alternative hypothesis? Mu not equal to 12. So it was a two-tailed test. What is the value over here? P value. It is for two-tail. So my test was also two-tail. My p value is also two-tail. So now I can make a direct comparison. So these are small things which normally are ignored. But here this is two-tail. P value is also two-tail. So now comparison is directly possible. If it was one-tailed over here, that means if it was mu greater than 12 over here, I cannot use directly this value. I have to take half of it. We'll do it in the other part, other example. So here p value is 0.100, which is greater than 0.05. Greater means what? If I get p greater than alpha means what? H0 is accepted. If H0 is accepted, what was H0? Mu equal to 12. That means what? It is up to the expectation. So the new variety of green gram is expected to give 12 hectares. So it meets the expectation. Any question? I hope it is clear. Great. I will take one more. Oh, I need L2. I'll rush a little bit. The same type of data it is. A researcher is investigating hemoglobin levels in school girls 15. Well, they want to check 15 school girls were randomly selected and the hemoglobin levels are as follows. Does the data reveal that the average hemoglobin level among the school is more than 11.5? And the data is given to you. Okay. Now, first step, H0. As I said, this is again about what? Average. It is not about proportion. It is not about percentage. If it was about percentage, we'll have to go for P. This is about average, so it is mu. And we take mu always equal to. Equal to what? 11.5. What was the data to check for? Is the hemoglobin, average hemoglobin level more than 11.5? This is what we want to check. And what we are writing down over here, it is 11.5 only. That means what we are saying over here, it is not more than 11.5. Why we are saying this statement? Because we always write down equal to. That means my statement is that hemoglobin level is 11.5. Can I say it is more than 11.5? No, because I am saying it is 11.5 only. So that means here the statement will be it is not more than 11.5. What will be opposite to this? It is more than 11.5. So that means mu greater than 11.5. So this is a one-tailed test. This is H1. So this is how null and alternative are decided. Once this is okay, step 1 and step 2 is done. This is okay. This is done. What is the third step? Third step? Anyone? Third step?
Assumption.
Assumptions. Now, how to check the assumptions? I'll go with that data also. I'll give an actual feel of it so it becomes easy for you to understand. Now I'll do it a little bit fast. I don't have to explain each and every output so that things are a little bit fast. So I'm opening my hemoglobin data file in which I have entered the data. Okay, this is my hemoglobin level. Now I want to check the assumptions. So where to go for? Analyze, descriptive, indescriptive, explore. Click on explore, select my decision variable, go into plots. In plots, check boxes normality plot. Click on OK. That's it. I'll be getting my normality plot. I'll be getting my plots also. So these are the plots. These are all plots. These are normality QQ plot. As I said, okay, I'll go with that also. Yeah. Here, what you are getting it? What is the value of P? Achha, what is the assumption over here? When we check the normality, data is normal against data is not normal. What is the value of P? 0.505, which is greater than 0.05. So that means H0 is accepted. So data is normally distributed. So my data is normal. So the data that we are dealing with, it is normal. So it is giving me a green signal to go ahead for a t-test. Now, as I said, the assumptions can be checked using Shapiro-Wilk test also and by QQ plot also. You will get your QQ plot in this way. You can see in SPSS output. This is SPSS output. This is QQ plot. Quantile plot. So here, if all the observations are very close, so you can see these are data points. If the observations are very close to this diagonal line, very close, that means it is normal. So this is a diagrammatical way to understand whether your data is normal or not. Okay. After that, what to do? Once we get a green signal, we'll go with analyze, compare means, one sample t-test, we'll select our decision variable, mu value 11.5. That's it. Okay. Answer. This is the table value again. This is all what this is the value that we are getting it. So my p-value, now understand this carefully. What was my null hypothesis? Mu equal to 11.5. What was my alternative? Mu greater than 11.5. So this was one tail. This was one tail. What is the p-value over here? This is for two tail. So what I have to do it now, p is equal to 0.214 divided by 2. This is how we convert a two-tail p-value into one-tail p-value, dividing it by 2. So my answer comes to 0.107. Now I'll compare, p is 0.107. I'll have to compare with 0.05, which is greater than 0.05. Right? My p-value is greater than 0.05. Greater means what? H0 is accepted. H0 is accepted means what? Mu equal to 11.5. So it is not more than 11.5. So the hemoglobin level among the girls is not more than 11.5. This is how all 5 steps are done. I hope it is clear. Wow, no questions? No questions. Good. There was a dialogue in Sholay. A.K. Hangal was saying that dialogue. Itna sannata kyun hai? I hope you all are clear with it. Concepts are clear. That is why you're not asking any questions. Now we'll go with the next test. Is t-test for 2 independent samples. T-test for 2 independent samples. When we are using t-test for independent samples, when data is normal, data is scale, it is normal, and we want to check average of 2 samples. Average of 2 samples. First step, H0, that means mu1 equal to mu2. Always it will be an equal to sign. Step 2, alternative. There are 3 options for it. Step 3, assumptions. First assumptions, normality. Second assumptions, we have to check whether the variances are equal or not. Whether the variances are equal or not. And that will be checking by Levin test, or we can check by F test also. And the third is the samples are normally distributed with no need to check. They are normally distributed because how the data is collected, we know it. So it is no need to check, but assumptions are there. Step 4, it is the same, T and P value. Step 5, conclusion is the same. So you can see more or less the steps are same. What changes is the null, alternative, and there is one more assumption about the F test. Getting it? We want to check whether the variances are equal or not. Right? Now I'll go with that. Achha, by the way, just to give you an idea, if the variances are equal, this is the t-test statistics that is used. And you might be knowing only about this. But if the variances are not equal, then also there is a formula for t that is called well t-test. Well t-test, where degrees of freedom are quite different. So no need to go into this complex formula. Software is doing the work for you. But just to give an idea that we are normally using only this because we are making an assumption. We are never checking. We are never checking the variances are equal or not. We still make an assumption variances are equal and we use this test. But actually, if the variances are not equal, this is the formula that we have to use. Okay, now the problem is this. In a fertilizer trial, the grain yield of paddy, kgs per plot, was observed as follows. We want to check, find whether there is any difference between the sources of nitrogen. So there are 2 types of fertilizers, one with ammonium chloride and the second is with urea. And this is the yield of crop. right? We want to check, is there any difference? So now the first step, we know H0, we'll always take it equal to mu1 equal to mu2. When I say mu1 equal to mu2 means what? There is no difference. Because what is the question asked? Is there any difference? We are always taking first step equal to, that means there is no difference. What will be opposite to this? There is difference. There is difference means what? What will be the sign? So let me write down in the chat box. When I say there is difference, means what will be the sign in between? Srinivas ji, Farida ma'am. What will be the sign in between? Whether it will be greater than, whether it will be less than, or it will be not equal. Yes? I think the chat is not working also. Okay, anyways.
Yes, sir. Now I have enabled.
Achha, you have enabled. Achha, I think it was on.
Nice.
Okay, not a problem. Not equal to. Now I'm getting the answers. I was surprised. I was not getting the answers. So, yeah. So that means it is not equal to. So mu not equal. So this is a two-tailed test. Now, but understand the main part of it, which when I did it from, as I said, CMC value, and after I came back and I was trying to do it on my own data, I was not able to do it. What was the issue that I was having was entering the data. What I was doing it, I was entering, suppose this is the data, then I was entering in the data like ammonium chloride, and I was writing down the value over here, 42, 39, 38, and so on. Here urea, and here it is 38, 42, and so on. If you enter the data in this way, SPSS won't work. And I'm probably, if I've not explained this, because that was a problem that I faced, that is why I'm saying you well in advance that don't enter the data in this. The data should be entered as one of the variable is yield and the other variable is fertilizer. So what you'll have to do, this is 42, 39, 38, 60, 41. This all are for what? Ammonium chloride. So we can make it as 1, 1, 1, 1, 1. Or ammonium chloride means AC, 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 AC. Then 38, 42, 56, and so on. This is for urea. So U, or we can make it as 1, 1. Enter the data in this way, then only SPSS will work. Otherwise, it will not work. So don't be tempted with the data that this is your X1 and this is your X2. If you do it, it won't work. And then you will feel that SPSS nahi ho raha hai. But actually, how to do it? You can see this. Okay, ye the null alternative ho gaya. This is how it has to be entered. Yield and the fertilizers. I have labeled the fertilizer as 1 and 2. This is how the data has to be entered. If you don't enter the data in this way, SPSS won't help you out in t-test. Okay. Category wise, yeah. Now, once you have entered the data, right? Step 1 and step 2 is done. What is the third step? We want to check the assumption. What is the assumption? The assumption was, what was the assumption? The data, that is this part is also normal and this is also normal. This is what we want to check. Data yield of crop for ammonium chloride is also normal and for urea is also normal. But the problem is we have not entered the data separately. We have entered in one column. So now what to do in SPSS? Again, go with the same thing. Okay, I'll show you with the actual SPSS file. This is the last example for today. We'll take, because tomorrow also Monday also I'll have to take a session. In that, we'll take with the paired t-test also, because I don't want to overburden you with and finishing with the content, because I want you to actually understand and utilize it yourself. Fine. This is the data. My third step is to check the assumption. So now I'm checking the assumption. How to do that? Analyze. Where to go for in analyze? Descriptive, explore. Okay, now the main part. Just go back with our simple first example that we took. It was only one variable, as I said. So there was only one column. But now my yield of crop is divided into two, urea and ammonium chloride. So that means I'll go with a dependent variable this, and my factor list is fertilizer. So what will this SPSS do? It will divide your yield into two, urea and ammonium chloride, and check it separately. So this is why categorical variable plays an important role over here. Fertilizer becomes our categorical. 1, 1, 1, 1, 1, 1, it depends, it is your ammonium chloride, and 2, 2, 2, it is your urea value. Now go with plots, go with normality, and continue. Okay. You will get an output, which is for, you can see, you are getting an output separately for ammonia, you are getting an output separately for urea also. You are getting for both. So this is the output that you will be getting it. Yeah. This is the output you are getting it. Separately for ammonia and separately for urea. You can see in both the cases, value is greater than 0.05. This is also greater than 0.05. This is also greater than 0.05. So they are normally distributed. The ammonia is also normally distributed. Urea is also normally distributed. If both are normally distributed, then only we can go for a t-test. If one of them is not, we cannot go for it. Right? Now, once it is decided that, okay, data is normal. So now I'm getting a green signal to go for the t-test. Now what to do? Again, go to analyze. Compare means, analyze, compare means in that independent sample t-test. So there are different t-tests, one away, ANOVA, paired t-test, independent one, and so on. I want to go for independent t-test. Once you go for independent t-test, again the same thing, yield, grouping variable is fertilizer. Now once, understand this part carefully, once you decide the grouping variable fertilizer, you will have to define that how you are grouped. So I have divided fertilizers into which? 1 and 2. So my groups are, group 1 is 1 and group 2 is 2. Suppose you have made it as A and U, A for ammonium chloride and U for urea. Then you have to write down over here as A, group 1 is your A, and here you have to write down this one. But it is better to code. So 1 and 2 is done. Okay, continue, click on OK. So this is what you will be getting it over here. This is our normality plot, and this is our statistics that you are getting independent. Am I missing something? Just let me know. Anyone? I have missed one point purposefully. What was that? What was that? Assumption. What was my one of the assumption? Normality. What was my second assumption, or what I wanted to check? Variances. Very good. I wanted to check whether the variances are equal or not. And I have not done. Actually, it is automatically done when you go for a t-test. When you go for this, it will first give you, this is an output, it will give you the f-test only. This is the f-test. And then it will give you the t-test also. So first column will actually have to be evaluated first. This is the F value, F test. And this is the significant value. So what is our assumption we are making over here? Variances are equal. And alternative, variances are not equal. What is the p-value we are getting? P is 0.01, which is less than 0.05. Okay, I'll make things simple for you. There are two p-values over here. If you see, one is for equal variance and the other is for unequal variance. So out of these two, which to use? For that, it is the third assumption, whether we are checking whether the variances are equal or not, we are checking this. So my p-value comes to 0.01, which is less than 0.05. Less than means H0 is rejected. That means variances are not equal. So now I came to know that variances are not equal. And so if variances are not equal, I'll have to use this part. If I got variances are equal, I have to use the first part of it. Getting? So the point that I needed to check, I'm already having in the output. So now I got that variances are not equal. So I'll have to go for this particular value. Again, this is for two-tail. What was our hypothesis? There is no difference. What was alternative? There is significant difference. Means it was two-tail. As it was two-tail, I can directly use this p-value. So what is my p-value? 0.011, which is less than 0.05. Less means what? H0 is rejected. That means H1 is accepted. That means there is significant difference in the yield of paddy because of source of fertilizer. That means ammonium chloride and urea are giving different yield of crop. This is how we are doing actual process. Step 1, step 2, assumption checking whether variances are equal or not, and accordingly we are using the t-value, t-test value. Okay, I hope it is clear. Perfect. Now, what is left out is paired t-test, but that I'll take it at my next session because I have to take the next session also. Okay, you want to unmute yourself? Any question you can ask?
Yes, sir. I have unmuted.
Okay.
Participants can ask their questions.
Good evening, sir.
Yeah.
Myself, Nesamani Sonja from Aligarh Muslim University.
Okay.
I would like to ask you, can we use pre-test for the, for finding out the difference between the pre-test and post-test?
Yeah, that is, yeah, we can use it. That will be coming. That is actually called a paired t-test. Pre and post is a paired t-test.
Okay, sir. Okay, sir.
And that I'll be covering. I actually was planning to cover it today, but probably I wanted you to have a clear concept. So I'll take it in the next session. So we can do it. Yeah.
Sir, thank you, sir.
So good evening, sir. This is Dr. Valan from Loyola College, Chennai.
Yeah, welcome.
Sir, the talk is really very much inspiring and it motivates me to learn SPSS with much more intensity. Can you suggest a book? Is there any book available so that I can do some personal reading?
For SPSS or for statistics?
Yes, sir. Yes, sir.
There is probably a good book which is data analysis using SPSS.
Okay, okay, sir.
And there are books, the same title and the same author. He has written on Excel also. He has written on R also. He has written on SPSS also. And now he has written on Python also. And they are good books.
The author name, sir?
I'm not able to recollect it exactly, but once I get it, I'll just send it over here.
Okay, sir. Sure, sir. Thank you, sir.
Yeah. Okay, I think there are no more questions. Nice to see that.
Sir, good evening, sir.
Yeah.
This is Deepa Kumaravelan.
Okay.
Now I have a doubt with how to, based on the normality only, we have to put the test. We have to choose the test. Is it right, sir? So we should not choose the test and we should not check the normality.
Exactly. Yeah. See, first of all, first you have to check your purpose, whether you are checking average, whether you are studying standard deviation or not, variability or not. If it is for average, and then check your level of measurement of your data, of your variable. If it is scale, if it is normally distributed, and you want your purpose, your objective is to check the average, then only you have to go for a t-test.
Okay.
I hope I have answered your question.
Yes, sir. Usually we will have this, we'll do this mistake. After choosing the test, we will do all these things. We will usually don't check the normality itself. We'll directly go with the test and we'll put the result, everything. So now it is very clear, based on the normality test, and we have to choose the correct statistical tools.
Yeah, exactly.
Okay, so
Good evening, sir. This is Chitranjan from Goa.
Yeah.
Sir, as you have given summary statistics for different tests, could we have table wherein we'll be able to know like different methods, like in experimentation? I am doing one of the study in my experimentation method. Which different tests that could be used when we have following experimentation as a method or quasi-experimental method?
I'm sorry, I'm not able to exactly get your question.
I mean, if I am following a experimental or quasi-experimental method in my study, statistical methodology will be followed, just like how you have presented your summary statistics. In case in a method like experimental method, survey method, as we have different methods in a research methodology. So can we have such tables, sir?
Yeah, so table, it is the same.
Nice,
that
sir,
yeah, I got your question now. The purpose, actually, that table is the same that I showed it over here, about which test to use when. And in that case, it is pre and post. You can use this also. Just 1 minute. Let me. Yeah, I think this is one slide that will help you. And this is the another slide that will help you to decide which test to use when. Yeah. So I have prepared a flow chart also.
Thank you, sir.
So this flow chart will help you a lot that to decide when to use which type of test. So is it over the single mean, it is for two mean, whether population standard deviation is given or not, and so on, you can decide it. So pre and post is also there. Here I have covered that dependent and independent part.
Good evening, sir.
Yeah, Subhashini.
I am Subhashini from IIT Gandhinagar.
Oh,
My question is, we have learned chi-square for the qualitative research method, but you have shown it in the quantitative way also. How is it?
Okay, good. See, chi-square, there are many tests that can be used for chi-square. Chi-square is such a test which can be used for parametric and non-parametric both. So as you rightly said, if it is for independence of attribute, then it is a qualitative test. In that case also chi-square can be used. But if you want to check whether a data is following a particular distribution or not, then again we can go for a chi-square test. If you want to check whether it is a particular data is having a particular variance or not, then also chi-square can be used. So chi-square is such a test which can be used as a parametric also. It can be used for a non-parametric also, depending on the purpose of your data.
Okay, as till now we have been learning t-test for quantitative and chi-square for qualitative. So one more query, like what do we find for the correlational research? How do we test it? The methodology is...
For correlation research, again, if your variable, if your data, if your factor, it is scale, then go for a correlation test, which I'll be dealing with the last session that I'll be taking it. But if your data is categorical. And if you want to check the causation for this, whether the two attributes are related or not, then we have to go for a chi-square test.
Okay, because my topic is work-life balance among teachers.
And what is a variable, how you are measuring that?
With motivation, job satisfaction, I haven't decided on the components yet.
So if you decide the component, and if that is scale, if you're rating something, if you're having a measure for it, then you have to go for a scale, then you can go for a t-test for it, pre and post or something of that kind. But if you're, or correlation test rather. But if you are simply classifying it, they are satisfied or not satisfied. If you're doing it in that way, then we have to go for a chi-square test, which I'll be dealing with in the next session also.
Okay, thank you, sir. Thank you very much.
Okay.
It was a good session and it was crisp and very easy also to understand.
Thank you. Thank you.
I think we have taken around 25 screenshots.
Oh.
Thank you, sir.
I hope this becomes
Good
very
evening,
useful
sir.
for your own research. Yeah. Hello.
This is Ari Karsan from Annamalai University.
Hmm.
Sir, is it possible to do the test other than SPSS software?
Yeah, very much. Very much. You can use Excel also. You can use Excel also. Some other time, maybe in some other platform, or Shaila ma'am can arrange for that also at a different time. The same thing can be done using Excel.
Okay.
And it is very simple. It can be done. It can be done using Excel. It can be done using R. We are, after this session, I'm taking a session at Parul University in which I'll be explaining to them about how to do data analysis using R software. And then for Anand Agriculture University, we are doing it for the Python also. So there are different software that can be used. SPSS is not the only part. There are many softwares that you can use it.
Okay, thank you, sir.
Okay, thank you.
Sir, good evening, sir.
Yeah.
Sir, I am Saravanupriya calling from Hindustan Institute of Technology. Sir, I am doing my research on information system in government hospitals.
Okay.
Whether I can use the same t-test, that is categorizing test for my research. The research is after giving training on HMIS, the health workers are updating the data into the software very well. But before training, they have not done the data. The data entry is not done correctly, and also the accuracy is very less. So I am doing my research on this one, sir. I have chosen only one GH, which consists of 42 health workers. Whether I can use this, adapt this t-test in that one, sir?
So, but how you have measured? Before they were not using it, not entering the data properly. So how you evaluated that? You have just classified, or you have given some score to that?
Yes, sir. I have given a score for the, for example, I have given 4 variables for data accuracy, data reliability, like that. I have given 4. Before
okay, I got it. I got
before
it.
training, after training. Okay. Okay.
Yeah, ma'am. So then you can use it per t-test. You can use it.
Okay, sir. Okay. Okay, sir. I can use similar test in different GH, and I can compile it as sir.
You can compare the accuracy. You can compare some other factor also. You can compare pre and post kind of thing. You can do it.
Okay, sir. Okay. Thank you very much, sir.
Okay.
Sir, there is one question in the chat box that whether we can do for politics or election survey.
Actually, it is in election surveys now. This is one of the biggest thing that has been used, and they are called the political analyst, data analyst, political data analyst, and it is a huge demand, huge field that we can do it. So yeah, ma'am, you can utilize for sure for the data that it can be done in this way. Just giving a brief example. Say before a particular campaign is launched, say in Uttar Pradesh or in Punjab, suppose a particular campaign is launched. Before that, what was the perception about say particular party? And after that particular campaign, what is the perception about that particular campaign? So that on that basis, we can decide whether a particular campaign is successful or not. So we can do it, pre and post kind of thing. We can do it. We can do a lot of data analysis. Even chi-square can be used. Even t-test can be used. Every game and statistics can be used, but accordingly you have to collect the data. And political pundits are doing that for sure.
Sir, there is another one question in the chat box by Abhilasha.
Yeah, I have read
The
that. Okay.
reliability.
Yeah, ANOVA and all. Yeah, we standard error, standard deviation is different, and this is also, these three things are different: standard deviation, standard error, and this is all three things are different. That we will discuss in ANOVA. Probably ANOVA is taken by Raju sir. Yeah, I think Raju sir will be taking about that. Standard deviation is for, actually, if I give a very brief idea, standard deviation is for observation. Standard error is for a statistic. So standard deviation or standard error is always for X bar, or it is the standard error is for small p. Standard error is for maybe small s. So standard error is calculated for statistic. And the formula we can see, if we are right on over here, it is sigma upon root n. So standard error utilizes standard deviation. And this is again mean square error and root mean square error. And so this is that particular part that has been utilized. It will come in ANOVA and it will be discussed in detail in ANOVA also. So don't worry. I think this question was asked before also, and I could not answer it because we didn't have time at that particular, but this question was probably asked before. And I think Selva has only asked before that. Yeah. Okay. Any other question? Okay. I think, ma'am, they are not having any question right now. Shalila, ma'am.
Okay, sir. Yes, sir. Shall we end the session, sir?
Yeah, sure.
Shall we end the session, sir?
Yeah, you can.
Sir, can you hear me?
Yeah, do
yes,
end the
sir.
session.
Yes, sir. Okay, sir. Thank you so much for your session, sir, on hypothesis testing. Today we have learned about null hypothesis, alternate hypothesis, left tail test, right tail test, type 1 error, type 2 errors, level of significance, and also we learned about one sample test, Bartlett's test, Wilcoxon test, Marvin test, Kruskal-Wallis test, test for one proportion, test for two proportions, binomial analysis of means. These terms, these statistics we were not aware actually. Shapiro, Wilks, and QQ plot. Everything, these terms were new for us. Thank you, sir. Your demo in SPSS on one sample test and independent sample test was very easy to understand. Your explanations about variances and the p-values gave us a clear idea to do data analysis. Thank you so much, sir, for being with us today.
Thank you.
As the participants told, the session was very interesting. Thank you so much, sir. We will be meeting again on Monday.
Yeah, okay. On Monday, we'll finish with this hypothesis testing.
Sir, as you told, we can have a session on Excel or Python in future, sir. Surely we will get the permission and we will have the session on it.
Sure.
Sir.
Surely, ma'am. Okay. Thank you. Bye.
Bye. See, the feedback form is posted in the chat box. Participants kindly make a note on it and fill it up, please.
Sarla, madam, thank you.